I want to ask our first presenters for today to come to the front. And we have Leonard Geier, Paul Methfessel, Tom Beckmann, Robert Hirschfeld from the University of Potsdam, presenting their project Asymmetric Performance in Virtual Reality and Code.
Thank you. All right, sorry, I have a bit of an involved setup. Okay, that's looking good. Yeah, hello everyone. So, yeah, we're from Potsdam. We are rather new to the community, and we've been looking at some of the things we've been doing recently in our group anyways, which mostly revolve around live coding and most recently VR. And we're wondering what sort of aspects might also be of interest to this community. And what we found we tried to condense in this work that we'll be showing you in a moment. So first of all, virtual reality, I suppose some of you have used it before, at least heard or seen about it. The part that interests us the most is this idea of having a full body accessible to you for interactions, and in a sense also a very rich and immediate feedback that you can obtain. So if you're inside of VR and you're interacting with something, you can literally see the thing that you're holding, and I am, from the computer point of view, can direct what it is. So if I'm trying to give someone feedback on the interactions that they're performing, I have a much more direct means to provide this feedback to the performer that is inside of VR, as opposed to them having to turn back to a screen, for example. Major drawback, if you've ever used VR, you've probably realized this. Entering text just sucks. It's just no fun. It takes ages, right? So looking at current ideas of live coding, which typically would involve text, at least all the forms that I've tend to have seen, it's not really suitable to be doing this entirely in VR. So as a first step to try and reconcile this idea of having this full body experience with great feedback with the idea of being able to even do any sort of live coding, we tried to combine the two benefits, the great efficiency of working with a keyboard and the great experience that you get from being inside of VR. So next, I'll briefly talk about the setup of our demo so that you can even understand what is happening. Then we'll show you that very demo. Hopefully it will work. We have a video backup otherwise. And then we'll go into some of the more technical details as well as a reflection and a discussion. So briefly, for you to understand, as I've mentioned, we have one performer that is at a laptop and another performer that will be in VR. The performer at the laptop will be programming the Squeak live programming system that you can see on the left, where we can create new methods that define loops of MIDI sequences that are supposed to be repeated. Whenever I save a method inside of Squeak, it will be automatically synced into the VR environment and also remain at the same position. You can see on the right-hand side, these gray blobs are supposed to resemble those methods that spawn inside of VR. The colorful circles will be cylinders in a moment, as you'll be seeing, and they resemble instruments. And the idea is that the performer in VR can take any of these methods with their physical hands and put them inside of these cylinders in order to schedule them for playback. Meaning the performer in VR has the option to decide when something is played, whereas the performer inside or at the laptop can decide what or how it is being played by literally modifying the source code. One aspect of interest or of relevance maybe, as it's kind of hard to see, the altitude at which the performer in VR is placing the methods inside of the cylinder affects the volume at which the samples will be playing, so that allows them to kind of fade in things or fade out, etc. Okay, wish us luck. Let's see. Okay, the tracking volume seems to have moved a bit to the right. Let's see how it goes. So I'm now in this Squeak environment, and I'll be starting by providing Paul with a simple loop for a bass drum. So let's do render bass. Oops. That window, yeah. Just good. Thanks. And I'll move on to define a loop here. I'll make the loop configurable so that Paul can later decide where it wants it to be played. And we will take a bass drum here for a quarter beat. And we'll have 4 of those. So the moment that I've now put this here, you'll see that this exact code has spawned in VR, as you can see on the right-hand side. And Paul can now take it and schedule it on any of the instruments. All right, that sounds pretty good. So let's do some more stuff and provide him with a hi-hat pattern. Okay, we're back. Nice, thank you. And for this, I'm actually gonna generate something here. And what this is essentially doing is I'm asking the system to generate me a pattern of 8s and 16s notes using open and closed hi-hat. This has now been copied to my clipboard. I can paste it in here. And Paul now has this method as well accessible. Okay, at this point, I will load the rest of the samples that we've prepared, and Paul can interact with the system.
Can you change the BPM to 140?
The BPM got reset when I was loading. So you can see that there's a lot of, well, maybe we should work on the organization, I suppose. Paul is now getting one specific type of method, which instead of MIDI node on and node off, generates MIDI control nodes. And you can schedule this as well to apply different effects to an instrument.
So can you maybe add a 1/4 at the end, where we have like 40 maybe as a number, and then we go from 40 to 100?
Control 2 as well, right?
Slide.
Like this?
Yeah, you have to, the first 100, you have to change it to 40.
Okay.
Yeah.
Okay, ich glaube, jetzt
Right.
kann man das einpacken. Ja.
Yeah, you can change the 40 now to 60.
In both? don't have it anymore. Ah, no, I got it. Okay, well, here you go. All right. Okay. Yeah, thanks for indulging us on this rather lengthy demo. So a couple words on this React MIDI system that has been running there in the background. You've seen that it's essentially been this idea of having these loops that generate MIDI events. In this instance, I've zoomed in a little bit on one of them. You can see we've defining this loop here in Smalltalk code, which gets 4 different inputs that get repeated, 3 or 4 quarter notes in that sense, a C4, C5, and then a rest. And you can see how this is a declarative loop in a similar manner that you might see in a pattern. The interesting part about this being somewhat inspired from the React.js system that you might know from web development is that in the moment that I change something, for example, if we assume that the timer is at the C5 at the moment, and I were to change this C4 to a D4 and save, the minimal change to make this thing happen will be applied to the running system, meaning without having to wait for a loop iteration to end, for better or worse. This will now immediately become the D4 as soon as the system reaches this point in time. So the idea really is to maintain as much of the state of the musical system that is running and reconciling it with whatever I change in the code, in the same way that React.js does hot reloading. If we contrast this to other systems that you're probably more familiar with Super Collider, of course, most of it happens on an imperative level, meaning if I want to update things, I can set new parameters to reflect the changes that I want to see. Or in SonicPy, where I can use named loops that when I re-execute the code, wait for the one loop to finish before the new code gets played for the next iteration. Why is this relevant to our system? Well, the interesting part here is that we, in this sense, maintain one very specific property, namely that everything that is visible in code is at all times looping, meaning the performer in VR doesn't really have to depend on any code that I might have deleted, changed, or anything, but rather whatever is currently visible is what is actually being informed by the system to be interacting, right? This doesn't necessarily mean that it's playing right now, at least not in the way we've designed it here, because the VR performer might not be scheduling these in the moment, but whenever they want to, they could do it. One interesting property of this is as well that we have great access to having long sequences that can evolve and then also be adapted while they are running, right? Because in the same sense that I can have one very long sequence of nodes, I can also introduce stateful variables. So for example, if I want an chromatically increasing arpeggio that just keeps repeating, I can introduce a state variable in my React code that maintains its state whenever I do a save. And just, for example, if I then change the exact distances that the arpeggio is playing, will resume from the current point that the state variable has reached. And another useful property specifically for this dualism of performing, I would say, is that errors are being shown to me at reconciliation time, meaning whenever I at the laptop press save, Paul can still interact with the system in its old state. Only once the system has verified that it can produce a new valid musical object tree, it will swap the two trees, or rather apply the minimal change, and then that becomes the new live tree. So if I have to deal with a mistake here that I did, Paul can still continue performing inside of VR, change whatever is playing, etc. So a couple of thoughts we want to leave you here that we noticed while performing with this. We noticed that Paul was really making the calls whenever we were trying out the system. That means, obviously, he was responsible for scheduling the nodes that were playing. So by the very definition, he was making the calls. But it was also interesting that he was asking me to perform certain changes, since I had all the power when it came to actually introducing new musical ideas that went beyond remixing simple ideas that were already present in the code. We also noticed an interesting dynamic where I was sometimes anticipating changes that he might be interested in, but also that I was sometimes exaggerating changes that he was requesting. So when he asked me to maybe lift something for an octave, I might raise it for 3 octaves, sometimes without him noticing in time, and then having this interesting dynamic of him having to get to terms with this change that wasn't entirely what he intended, but what I sort of threw him there as an opportunity. One thing that you've also seen Paul do briefly in the demo was using the VR methods as almost like a percussive instrument, where he was sliding them up or like quickly toggling them between different instruments, having this sort of more beat like quality to them as opposed to just being a simple loop that keeps iterating. And one best practice that we noticed over the course of using the system was that it was really helpful for us to split melodic ideas into different methods so that Paul could swap them out individually and decide, okay, now I want a different hi-hat pattern only, but keep that drum pattern as a base. So a brief look into the future. One of the more obvious things is that we want the VR controller as this amazing analog means of providing input to be able to also provide more input than just scheduling things. One idea would be to expose more parameters, but in the more general sense, we could allow the VR performer to point at any variable in the code and modify its value by changing the position of the controller, for example. One other thing that we noticed while performing was that having this idea of transactions or groups of instruments or other methods might be of value, because it was rather difficult for Paul, as you've seen as well at the end, to sort of make the performance stop because he had to individually collect all the different methods that were playing at the moment. So doing something like a break is obviously not really feasible if you have 4 instruments playing and only 2 arms. And one aspect that might be of specific interest to this community is that you've seen the code was quite verbose, and right now this is mostly because that's sort of the level of verbosity that we were comfortable with dealing and also understanding it when we were handing it around. But I think it is quite viable to also maybe embrace some of the ideas that we've seen in Tidal in terms of patterns and similar things to make this more conducive to really improvising also on the laptop, not just in VR. So if you're brave and want to try the system, there's the link. I will warn you that it is a rather cumbersome setup, which is also why we were grateful to be able to swap to the first slot here. But yeah, if you have any questions on this, we're also happy to answer you in the GitHub issues. And with that, thanks for your attention.
Yes, thank you, Tom. Thank you, Paul, for this, also for the wake-up performance, basically, for all of us. Next up, it's Ian Clester. I must look for the full title. He will present his paper, LambDAW, towards a generative audio workstation, and he's coming from the Georgia Institute of Technology. Also, questions and discussion we do at the end of the session. All the papers are quite different in one way, but very similar in the other way, that they extend or implement live coding technologies or the live coding paradigm into a different domain. And so is Ian once he's plugged everything in.
Okay, I'm going to test the audio again. Great. Okay.
Cool. Stage is yours.
Hello. Thanks, Patrick, for the introduction. I'm Ian. I work in the Computational Music for All lab with Jason Freeman at the Georgia Tech Center for Music Technology, and I'm here today to tell you about LambDAW and how this is a step towards a generative audio workstation. So LambDAW, the name has 2 components. Perhaps the most obvious part is DAW, because it's in all caps. And that, of course, refers to the digital audio workstation, right? And so this in particular is Reaper. And DAWs generally have a bunch of tracks in parallel. You can see them in the mixer. You can see them in the timeline and arrange items in them. And you get this very nice interface for doing direct manipulation, right? You can just drag things around, say, I want this piece of musical material to occur at this time, and I'm going to put it there. The other part of LambDAW is, of course, Lambda, which gets elided with the DAW. And that refers to the Lambda calculus, computation. And in this musical context, that brings to mind for me things like patching systems like Pure Data or Max, and then also computer music languages like Super Collider, and of course all of these wonderful live coding languages that are built on top of it. And so the basic question for LambDAW is, can you have the best of both of these worlds? Can you have the direct manipulation of the DAW and this ability to just bring in material from wherever and use it? And can you combine that with the flexibility and the power of code and the ability to make your own musical abstractions and use them? And another way to put that question is sort of looking at it from the DAW perspective. OK, I have audio items. I have MIDI items. What if I have musical material that is a computational process? What does that correspond to in the timeline or in the DAW? So I'm going to talk a bit about related work, but before I do that, I want to show you like a 20-second demo just so you have some idea of what the thing is I'm actually describing. So here's that. Let's see. I did plug in the cable, and it did work a second ago. Is this? Oh, no. I have a bunch of videos, so we better take a second to get this going. Let's see. OK, I'm just going to mirror my display instead and see if that works. Sorry for the delay. OK. Let's keep the changes, not go through that again. All right. This is what I get for switching from Google Slides. OK, I will try one more time.
Let's say we have some musical material that we recorded with a MIDI controller like this. Then LambDAW can create an expression item that refers to that material and transforms it, like this. As soon as we enter an expression, it's evaluated to generate the contents of the item.
OK, so if you only get one thing from this presentation, it's that. Like, that's the basic idea. And the rest of this is just expounding on that and why I think it's good. So a moment for related work. So if you think of computation in the DAW, this is probably the obvious thing to think of is plugins, VSTs, audio units, all of these things that let you add some computation into the effects chain, sort of an analogy to physical effects pedals. And these are really useful, but they sort of apply for all time generally. And also there's this separation where usually these are sort of already built for you. You're not, I mean, there are a few interesting exceptions, but generally you are not composing a VST at the same time as you're composing your piece. And then in live coding, of course, so from the DAW perspective, we're taking code out of the effects chain and putting it in the timeline. From the live coding perspective, we're taking it out of the editor or out of the IDE and bringing it into the DAW. And LambDAW draws on this emphasis on brevity and expressiveness as an inspiration. And You can also make an interesting comparison with code jockeying practices. So this is a screenshot of Dead Code by Jamie Beverly. And in LambDAW, we'll talk about live coding with LambDAW in a minute, but the sort of normal mode is this compositional mode where you're working on a project, writing expressions, changing the expressions, seeing the output. And there's sort of an analog here with building up a collection of live coded snippets that then you trigger later in sort of this session view-like interface. Then Jabberwocky, which by Charlie Roberts and Graham Wakefield, claimed the title Live Coding the DAW, which is a really good paper title that I wanted. But the model is a bit different. This is more like you have a Max for Live device, and then you can live code that and have it output things according to your live coding. So it's still more like using Ableton Live in that case as an engine for performance more than a sort of compositional environment with a timeline. And then I work on EarSketch, so I have to mention it. But this is a pedagogical tool for teaching students to code by making music and vice versa. And it very directly just juxtaposes a DAW and an editor. But there's not really an integration between them. And you have this script that sort of generates the entire DAW project in one go. OK, the main inspiration, though, is this stuff on end-user programming. OK, so everyone loves this thing, right? It's a 2D grid. You enter some data. We're already off to a great start. But the really cool thing is you can enter formulas, right? And you can do that anywhere you would enter data. This is an old idea, right? This goes back to like VisiCalc. There's a really great quote here, which is going to look like long for a slide, but here it is because I think it's so good. All right. When software allows adding dynamic behavior as part of gradual enrichment, it supports programming in the moment. Spreadsheets support dynamic behavior with live, reactive, declarative formulas that you can place anywhere you would otherwise have data. They treat data and formulas equally, where they appear in the interface, how they're edited, and how they reference each other. This interchangeability supports programming in the moment by allowing you to keep working with the same tools and the same mindset, thinking only about the specific thing you're modeling, even though you've switched to programming. They don't force you to stop and switch to your programmer hat. And I think this is maybe the nicest paragraph anyone has ever written about spreadsheets. And so I've included it here because I think it's really inspiring. I mean, it's sort of it's prosaic office software, but it has this amazing feature where you can bring in computation and do it without first becoming an expert, and it pays off very quickly. OK, on that note, there's an interesting project by Chris Nash called Manhattan that sort of does this for the tracker interface, which is quite like a spreadsheet. So you can use expressions to determine various parameters. It also supports control flow, which is neat. There's also some things you can see in proprietary software like After Effects, where you can put expressions to determine properties of animations. And then there's these ink and switch projects. That's who I stole that quote from. Potluck and Inkbase, which both let you do some of this end-user programming in pretty free-form environments, like just an arbitrary text document or a sketch. Really cool. And then computational notebooks, probably everyone is familiar with. This sort of goes in the other direction, right? You start with code, and then you're enriching it with Markdown, LaTeX, widgets, plots, all of these things. And that's another inspiration for LambDAW. OK, so what even is LambDAW? Like you saw like 20 seconds earlier after I got the video to work. But it's basically this. So you have a DAW. You have a programming language. And you have time. OK, the DAW in this case is Reaper. The language is Python. And then you have these embedded snippets on the timeline. OK, so remember that thing with the 3 pieces? Oh, what is the code piece? OK, it's expression items. So you can turn any item into an expression item with a little equal sign, sort of like in a spreadsheet. And so I'll just show a couple of examples, probably not all of them in the interest of time. But let's see. Hopefully video still works.
Expression items can also generate MIDI directly. So for instance, we can arpeggiate a chord, and let's choose between 2 different options. Okay? And if we reevaluate this, sometimes we get the other option. Expression items can also have names so that we can refer back to them from other expressions. So transposed.
And I think I'll show one more. I'll skip around a bit. Let's see.
And expressions can also refer back to other audio items. We'll see that here, where we also show how we can use an external library, in this case, RAID, to process audio. Here's the original. And then here's our derived item.
Yeah, there's a few more examples, which maybe I can come back to if I unexpectedly have more time. But for now, I'd like to move on. So you might have a very reasonable question looking at this, which is, OK, this is very nice for like cute one-liners. What about when things get more complex, or when you want to build your own abstractions? How does that work? And the answer is project modules. So every DAW project has an associated Python module that gets loaded to establish the environment that's used for executing these expressions in the items. So this is Python, so you can, there's a nice ecosystem. You can import lots of things, like Raphael was talking about yesterday. And so, for instance, you might put imports in your project module. Standard library imports like math and random, very useful. You might pull in some music theory libraries, or you might pull in Aleatora, which is a library of mine that you can use to synthesis things. You can also build up custom definitions in here, so like transpose or arpeggiate, which you saw before. And then you can also, for instance, just run external utilities and have that triggered from evaluation in the DAW timeline. And then finally, you might be wondering how, if you refer to another item in the timeline by name in an expression, you're using it just like a Python variable. How does that conversion work? So there's a default behavior for converting audio and MIDI items and for converting iterables back to these from Python, but you can override this behavior. So say that you want strings, any expression that returns a string, to automatically go through text-to-speech, then you can define a custom converter that does that for you. OK, now here's the main demo. Hopefully, yeah, I think we're good. So I'll play most of this.
So if we start recording, LambDAW will look in track titles for expressions. If it finds any, then it will create items with that expression and their title in each upcoming cycle. So here we have a little bass drum. Let's use a different sample. OK. Then let's add some hi-hats. Let's make the pattern a little bit fancier. And let's also randomize the amplitudes.
Okay. Thank you.
Thank you, Ian.
Do I have, okay. You want to? Oh, I just wanted to mention future work. Yeah, sure. Okay. Yeah, there's a lot of things here to discuss, which maybe we can do at the end of the session. But just in terms of future work, I wanted to mention, you might have noticed during that live coding session some hitching once I added enough things, like the UI paused a little bit. Right now, all that evaluation is just happening in Reaper. I'd like to move it out to a separate process so that, well, for a bunch of reasons, but one of them is so as not to block the UI. Reaper is pretty cool and also supports video and subprojects and all of these types beyond audio and MIDI that would be nice to work with. Big question for me is how to make this reasonably accessible to people. I think just saying, okay, here's an empty Python module, figure out what's good to use is maybe not the right approach. So maybe it'd be good to have some kind of starter kit or default module to work with. Another question there is how to encourage people to use this without feeling bad when I break it inevitably. So I'm open to suggestions on that. And yeah, in the long term, there's this vision for having an audio workstation that's as adept at working with generative audio, generative music, as it is with digital audio. And this is a step, I think, in that direction. But there's still, right now, after you evaluate, you still have a fixed output. And in the really long term, I would like to be able to export a generative piece directly from the DAW that preserves that generativity of the items. I don't think I'm especially close to that, but that's part of the long-term vision. Okay, now I'm done. Thank you.
So, thank you, Ian. Next up is Dimitris Kyriakoudis, vielleicht, maybe. Okay, great. Presenting his paper, uSEQ, a Lispy modular sequencer for Eurorack with a Livecodable microcontroller, and Dimitris comes from the University of Sussex.
Signal? Oh. The other way around. Okay, hello everyone. I'm going to be talking about uSEQ, which is a Eurorack sequencer module that I've made with my one of my two PhD supervisors, Chris Kiefer. So, my name's Dimitris Kyriakoudis. I am in my second year part-time PhD at the University of Sussex, where I'm studying live coding instruments and instrument design and practice with Chris Kiefer and Thor Magnusson. And we're part of eMute Lab, which is the University of Sussex's lab for experimental music technologies. So both Chris and I are we're live coders. We have been for a while. We've made our own languages. We make digital musical instruments. We play physical instruments as well, feedback cello, the piano, saxophone. And we are very passionate about modular synthesis. And we really like performing. So instruments to us are a way to sort of have this sort of in the moment connection, especially when performing. And we like live coding, we like hardware modular synths, but there are some problems. So with live coding, for example, we find that we already spend way too much time in front of laptops as it is. And the fact that our other interests and hobbies are also computer-based really don't help in that. I'm sure a lot of people can relate. And then we often find that it lacks some of the embodied and sonic qualities that we find in other instruments. And so we're looking for ways to mitigate that. And then with hardware modular synths, perhaps one of the first thing that people will notice about the practice is that it's not the cheapest thing. There's a reason people call it Eurorack. And specifically when it comes to sequencing, the sequencers can be a tiny bit too large sometimes, or they can be a bit too rigid in the sort of music that they allow you to sequence, or they can be a bit menu divey, which is not fun when you're performing, or in general. And generally, they can sometimes get a bit boring playing with them. And if you don't believe me, these are some of Eurorack's most popular sequencers today. They all cost perhaps north of 400 euros just for a sequencer. It doesn't make any sound. And the user interfaces leave a lot to be desired, I think. So we were wondering, what can we do about this? Is there any way that we can sort of combine our passions and get some kind of synergy going on between live coding and modular synthesis? And then maybe, hopefully, at some point in the future, make an actual product out of this. So to begin with, our high-level goal is we want to make the combination of live coding and hardware modular fun. We want it to be a sort of a system that we ourselves would enjoy using in our free time. And we want to keep what's best about each practice, and there are different things that are best about each practice, and we want to try and mitigate each practice's worsts by sort of with a combination of the other's best. And to do that, we really need to identify, understand, and mediate the tensions that may arise between these two practices, and we'll talk a lot more about that in a bit. So those tensions can be ergonomic in the sense that the two instruments work differently with the body in space. There might be sort of fragmentation of what your body is doing. You need to move from the laptop to the modular and back again. Or there might be ergodynamic, which is what the instrument feels like to be played with. How does it guide you, and how does it inspire you, and in general, what is it that you perceive from the instrument that it wants or it can be used for. They can also be embodied and cognitive. So there's a lot of tension that might arise if you constantly need to switch between different cognitive modalities, if you have different ontologies that you need to somehow reconcile, if you constantly need to be switching between thinking about the syntax versus thinking about the knob positions on the modular. And lastly, some of them can be creative and aesthetic. So live coding and modular synthesis are in a lot of ways polar opposites. In the sort of results that they can create, or the process that through which they create them. So we want to try and see what their sort of in-between combination and common ground could be. And ultimately, we just wanted to make a live coding sequencer that we wish was already out there. So our main objectives for this project was we wanted it to be limited by design. We wanted to make a sequencer. And we wanted it to be accessible. So it had to have consistent identity that doesn't change over time. It's a sequencer. It's not another module that can be anything you program it to be. There's quite a lot of them out there already. And we wanted it to be fixed firmware. So you flash it once, and then you live code what's been flashed on the module. And then for accessibility, we wanted it to be affordable. As we saw, some of the modules are quite sort of high-end and expensive, really not accessible to newcomers. We wanted it to be DIY friendly. It's a very simple hardware design, and we believe that it can be built as a weekend project by an enthusiast. And of course, we wanted it to be open hardware and software, which are philosophies that both hardware modular synthesis and live coding really have at heart. So that leads us to our research questions, which can be stated as such. What are the ergonomic and ergodynamic tensions that arise between the practices? And how can we mediate them effectively, affordably, and scalably? So in a way that would, if we wanted to go really crazy with it and live code everything about the modular, we could expand this system to do so without breaking the bank. First, we took a look at the two practices and we tried to understand what it is that makes them what they are and how they compare in a lot of their sort of ergonomic and ergodynamic characteristics. Firstly, and what I think is perhaps one of the most important ones, hardware modular synths are very limited. You select your modules a month in advance of a performance, you put them in your case, you don't swap them out all too often, well, some people might, but and you definitely don't want to be plugging and unplugging them into the power supply while you're performing, although I'm sure some people have also done that. And repatching them is definitely possible, but it's tricky, especially if you only have one patch cord that carries the sound. Repatching it means a temporary break in the sound. Whereas with live coding, we're more or less unlimited by, we're only limited by our CPUs and our minds. So elements can be cloned forever. We can have 1 billion oscillators if our computers can handle that. And then we can replace any part of the stack. Famously, Extempore has the neat party trick where you can change the definition of an oscillator and have every synth follow along and jump up an octave or two. All the patterns that are currently active in a live coding set can be, if you wanted them to, can be swapped with just the press of a button. So there's quite a lot of flexibility and potential, which might be overwhelming to some, but also might be very welcoming to others. But also, hardware modular synths are almost by design very imprecise. The knob values aren't always labeled. You don't really know what frequency your cutoff filter is set at. You don't know the exact decay in milliseconds of your envelope. And that's by design. The modules want you to play them with your ears and not with your prefrontal cortex. And this is one of the best examples, perhaps, the maths module, which is arguably the most popular Eurorack module. It has maths in the name, and yet I don't really see any numbers around the dial. So it's fascinating to me how they invite you to just close your eyes and tweak and see what sounds best instead of trying to round up to the nearest multiple of 5. Whereas with live coding, there's a very explicit precision that's required. Values have to be specified precisely. You can't just say something around 40. You need to say either 40 or 41 or 40.5. And then it encourages the user to build an intimacy with the numbers over time. So you build a personal relationship with certain numbers. You get a feel for what combinations work best, but you're explicitly encouraged to look at the numbers and try and sort of build a sense for how you want to play with them. And then on the other hand, it's inherently accurate and deterministic. So analog synths are infamously sensitive to temperature changes or what time of day it is or whether you had a good breakfast or not. But live coding and computing in general is quite deterministic and quite sort of quite accurate and on point. So there's really very little room for vagueness unless we explicitly add that in using randomness, which in a lot of cases is also deterministic. And then something that's very important for the user and the player is fault tolerance. So we're dealing with really complex systems. A lot of what we're doing with them is guesswork at best as to how it's going to work out in the end. And then hardware modular synths have, for a long time now, been designed in a way that are kind of child-proofed. You can just patch anything into anything, and worst case scenario, you don't get any sound. Best case scenario, happy accidents. And there are no compiler errors. You don't get confronted with cryptic messages that might confuse you and distract you during a performance. Whereas live coding and coding in general is quite strict about correctness. I mean, the wrong semicolon or a missing comma here or there can and will break your code. And this is just a Haskell compiler error for just changing a hash symbol to a $sign. So there's a lot of room for improvement there, and a lot of people are working on that. But as it stands, modular synths are a lot more inviting to have you mess around with them and sort of not worry about your laptop catching on fire if you type in 1,000 instead of 100. Lastly, modular synths don't really allow you to recall presets, so they invite you to just have a sort of in the moment, lost in the ether forever relationship with your system and your music. And if any of you are sort of involved with modular synths, you know that there's a very certain feeling associated with just removing everything and starting from a patch from scratch, which can be like just deleting all of your code if you've built up some code over a session. But the tricky part here is that live coding allows you, if you want to completely preserve what's happening, save it to a file, come back to it a week later, and it will still be there. The last thing which I personally find very interesting for me is that live coding requires your hand to be locked in place. You're just mostly doing this. You're not moving around. Your hands are not moving around. Your body definitely isn't. You need to be sitting in front of your laptop, at least as it stands now. And that's something that I'm sort of looking at different ways of changing in the future as part of my research. And perhaps one of the best ways to show that is just look at these images. They're very, very different practices. So on the left, Colin Benders is a very famous modular synthesist who's also happens to be from Utrecht. And he's known for having these massive monster modular synths, which probably cost as much as a brand new car. But you can see that his studio is a place where he's just moving around from one part of the desk or his setup to another. He doesn't even have a chair right next to him. He's not sitting. He's sort of physically moving around, and with that, I am imagining mentally moving around as well throughout his setup. Whereas with live coding, you are sort of there, and you have this enormous degree of information complexity that's just confined to 13 or 15 inches of a laptop screen, and you're kind of focused on that one spot, and your eyes are, your body is, your hands are, and everything. So if we're to bring these two together, we need to find a way to deal with that kind of tension. And then lastly, just to give another example of a lot of information complexity and density, this is Richard Devine's modular setup. Not a lot of people have this, so this is definitely an extreme case, but you can see how there is a layout in space, and all this information complexity is distributed across his monster modular, and there's a lot of visual feedback in the form of patches, which can get a bit overwhelming, but also a lot of blinking lights that trace along what's happening in the music. So very quickly, I want to talk a little bit about some of the context that exists already. We identify two types of solutions to this problem. One is computer to modular, and then the other is computer in modular. And spoiler alert, the second is what we have chosen for ourselves. Computer to modular is, there are two main solutions. They're basically audio interfaces that allow you to send code, but they don't really run the code on themselves. They require your laptop. They're mostly made for multi-track recording, so they have more inputs than outputs. Don't really offer any hands-on controls, so you're left to your digital devices for that. And they're proprietary and pretty pricey, so not really what we're looking after. Computer in modular, on the other hand, is a lot more interesting, and there's only 2 modules, as far as we can tell, that allow you to live code in modular. One was presented at ICLC last year, I believe, by Alejandro Dimitris, and it's called Code, and then the other one is the Monome teletype. And still, both of them have some issues that we weren't happy with, so they opt for displays, but they're small displays relatively, so it's not particularly practical to use them for coding. They are, again, general purpose, so they don't guide you in any way or limit you as to how you're going to use them. And so we chose to instead develop our own, which we call uSEQ. U for the Greek letter mu for micro, and capital Seq because it's a big sequencer in a small package. Here it is in this room. This picture was definitely not taken 20 minutes before my presentation. And it has a number of specs which I don't really have all the time in the world to go into, but it has, the main part is 4 digital outputs, so 4 outputs that can send gates on and off, triggers that, that can have arbitrary lengths. It also, we recently added an expansion port, so we can have as many of these as we want peppered through a rack, and they can all be synced together without sacrificing any of the inputs. So a little bit about the hardware that's running on it. We chose to go with a Raspberry Pi Pico. It costs around €5. I got mine for £3.50 before inflation got too crazy. It has quite a bit of I/O, so it allows us to have all of these inputs and outputs on the module, which is great, and quite a bit of sort of processing power and storage space to work with. And then we built the first prototype on a breadboard. This is the one that you see in the paper. Now we have a PCB for it, which we're testing, so hopefully we'll be able to put together a little DIY kit. A little bit about the DSL. I'm going to probably rush through it a little bit because it's not something that you've never seen before, and also I want to get to the video before I run out of time. It's based on a Lisp because it's a small language core. It allows for really tiny interpreters that can fit on a Raspberry Pi. It's surprisingly hard to find interpreters. Well, maybe not surprisingly, actually. But it's hard to find interpreters that can fit and run decently on the Raspberry Pi Pico. They're pretty performant, and they allow the user to change them through metaprogramming, which we talk a little bit about in the paper as well. And we chose to go with a signal-style DSL. I'll give you some simple examples. I can skip through this. You can read that in the paper, but this is the modification that we made to the REPL. So instead of just blocking and waiting for input, it just checks to see whether there's input, and if not, it just keeps going through the update loop, which runs anywhere from 100 to 700 times a second. Some code examples, pretty basic stuff. You can read a lot about this in the paper, and there's a tutorial that we're working on for the GitHub repo. And then finally, because I'm running out of time, I'd like to show you a picture of it being live coded from a tablet. So the tablet doesn't need to run any of the code; it just needs a serial connection to be sent to the module. And what we like about this is that it doesn't force you to switch between having a laptop and the modular, which you will see me doing in the demo video. And the way that you connect to it is through a hacked USB cable that has a mini jack on one end. So you can literally just plug into it, and if you have 5 of them in your rack, you can use a multiple and send code to all of them. Or a bonus picture of the 3D printed faceplate, which can save a lot on cost. Total cost we estimate to be below £30 for raw materials and everything else you need. And for the video, oh, that's not great. Yeah, I can try restarting. 1 second, sorry about this. So it shows up here. Oh. It's not on YouTube, but I can just find it on my Google Drive quickly. Yeah, it's right here. I'm not sure why it wouldn't be playing. Ah, there we go. So this is live coded from a laptop, and you can see some of the issues with moving between the two. Try this maybe. This is being live coded through the Arduino IDE. And I'll just skip ahead a little bit to the, oh, this is the dramatic finale. So, yeah, thank you. So, very, very briefly, what we learned from the project, we really like how we have a bare bones software stack. We don't have that many dependencies. It allows us to feel like the module, it can be put in a case and just forgotten about, and we're not going to run into updates that break things. There's a very clear scope to the module. It's just a sequencer, so when we're live coding it, we're not constantly thinking, oh, maybe I should tweak my synth defs or whatever. It allows for quite diverse musical outcomes, and it's quite small and cheap, and it sort of tries to, as far as we can tell, it works well with Eurorack's philosophy of everything is a signal, sanitize your inputs, and so on. We don't really like that the Pico doesn't allow us to have many CV inputs, so it's quite limited in that sense. And the refresh rate of the update loop, we'd like it to be a bit faster, and we're working on sort of optimizing the interpreter that we're using. And if anyone wants to contribute, please do. We learned that using dependencies that have documented source code are invaluable. It's really hard trying to patch an interpreter that was written in 1980s style C with global pointers and mutation everywhere, and maybe 5 comments in the whole, what was it, 6,000 lines, 9,000 lines file. Lisp is a very good choice for this, and especially we want to look at sort of projectional editors that use touchscreen interfaces for direct AST manipulation in the future, and then you can just live code with your tablet. And then 3D printing module panels is a viable option. We need to do a little bit of fine tuning to get the module looking nice, but it definitely is functional and it works. Next steps are custom code editor, as I just said. We want to make things a little bit faster and snappier, but that's not a breaking problem. And we want to maybe try and use other microcontrollers or a wireless one. So this is the GitHub repo. Please get involved if you like. And I have a module here with me, so if anyone would like to see it, yeah, please come talk to me, and we can geek out about it more later. Thank you.
So, thank you, Dimitris. And you can just stay right here. And I ask also Ian and the other guys to come up. And we have some time for questions and discussions. And there is already a question back there by Niklas. Come up front.
So this is more or less a question to all the authors.
So to answer in my case, repeat the question. Yes, sure. It's whether a lot of our projects seem to involve limitations by design, and whether we believe that it forces us to sort of exert more control, and whether we have to think about it more. Is that okay? So in my case, in our case with the modular, a lot of control is being delegated to the modular itself. There's a lot of other kinds of limitations by design in that system, but as the code is only responsible for one aspect of how the music is being made, and that kind of frees us to not have to worry about, I mean, we can still be loose and use a lot of randomness and stuff like that, but then it's up to the rest of the modules and how they want to deal with that sort of thing. So it puts a clear scope around what the code is supposed to do and expected to do.
Yeah, for our use case, I think it's also an interesting dynamic because of the inherent limitations that the respective system, the VR system and the laptop system have. So by the very definition of how it's split up, they codepend on one another and have to deal with their respective limitations and communicate to overcome them, unlike systems where you might be collaborating on the same level. Mm-hmm.
Yeah, and I suppose in the case of LambDAW, there's not designed in limitations really in the same way, but there's sort of natural ones that arise from the UI. Like you don't want an expression that's too long because then it's like you have to zoom in really far to see the whole thing, or maybe it's just too wide. So there, yeah, I think you still have the same kinds of questions about how to manage complexity that you do with any kind of software thing, but the tools you have available are a bit different. Like you can set up relationships between different things, or you can say, all right, let's bail out and like put some more stuff in the user project modules. Yeah.
More questions?
Yeah, so I have a question for LambDAW about used Reaper in the demo, and I imagine it's because it's easy to build the things you did in Reaper. So what would you say, how much work would it be to use like Logic or Ableton? I ask because I think one of the great things in Ableton is that you can control a lot of the plugins via, like, for example, MIDI. So you could also not only use lambdas for generating notes and stuff, but also use it, for example, on one slider you put a lambda or something like that.
Yeah, thank you for the question. Yeah, I'm definitely interested in making it general and not be so tied to Reaper. Reaper is very convenient as a starting point because it's quite hackable. It has a RiaScript API, and there's also some third-party modules that make that nicer to work with, like RiaPy. But yeah, I'd like it to be something where you have a variety of options for the DAW. I looked a bit at how scriptable other DAWs are, and I came to the conclusion, like, this seems pretty doable in something like Ardour or maybe Xerothum, which are also have full scripting APIs. I'm not sure how easy it would be, or if it is possible to do it in Ableton. Perhaps people who have done more hacking on Ableton can tell me. Yeah, that's definitely an area I want to work on.
The question for the first session. Can you tell us a bit more about the reactivity, like how it was implemented and what were some of the challenges?
So in essence, the reactivity that we have is a port from the React.js model to Smalltalk. And the way that React.js works, very briefly, would be by constructing this virtual DOM idea, which we are essentially doing as well, just with constructs that make sense in our context. So it's not diffs and inputs and what have you in web, but rather they are loops, they are not on, they are not off events. etc. So in the end, we obtain an object tree that can be continuously interpreted. And the reactivity then arises by looking at a new version of that same object tree and the virtual representation of it, creating a diff between the currently running and the new tree, and then applying the minimal change. So that means all of the state that I haven't touched is still intact, etc. And yeah, that allows us to very nicely swap in and out live while the whole system keeps running. Hope that answers your question.
Yeah, something struck me about all the presentations is that when you start dealing with direct manipulation, then you have to cope with mess, like whether it's this growing timeline that you then have to decide what to do with, or this tangle of wires, or this these virtual bits of paper that you then have to work out how to file. Yeah, and that, I guess that becomes part of the performance then, is kind of handling this mess or tangle. Wonder if you had any comments on that?
Yeah, I'll address the infinitely growing timeline. Yeah, so LambDAW, it's sort of two distinct modes of composing and generally like not having the transport running while you're doing stuff, and then sort of the improvising or live coding where you have the transport running and it keeps generating new items. And in that case where it keeps generating new items and you get this timeline that's growing and growing, I think of the timeline then as not something you're really interacting with directly, but as sort of the residue of the performance, right? So when you're done, you end up with all of these items that serve as a record both of what output was generated, the audio or the MIDI, and also what code generated it. So in that case, I think that the mess is sort of just a reflection of the mess of the improvisation, which I think is a nice thing to have. Yeah, I think there's a question, a related question of like, if you're just composing with this, then you accumulate more and more things in the namespace, maybe things get out of sync, and that's another kind of mess to deal with, perhaps.
So ties back a bit to the first question about limitations. I think that it's interesting that we have different limitations. That would be a kind of limitation if you have too many methods in our system. For example, it becomes just unwieldy, which is with normal live coding, it's easier to work with. So it's interesting to see that if you have limitations in one space, you tend to get creative in the other spaces that are open for you. So I think limitations here help creativity. So in a way, it's maybe not that bad that we have them.
So in the case of live coding and modular, I mean, arguably there's direct manipulation going on when you're typing code as well, and I often end up in messes of like 10 or so blocks of code in my screen or around it, and only one of them is doing something, and I'm sort of trying to sift through all that it does. And what I find is that you over time develop the skill of tunnel visioning, perhaps, of just learning to focus on exactly the one wire that you care about right now, or the one knob that's hidden beneath 20 wires. And you sort of learn to ignore a little bit of the complexity. And then for me, my personal approach is when it gets to the point where it's too hard to do that anymore, it's time to unpatch everything and start from scratch. And what I take out is the experience and the knowledge of what I did that I liked in that patching session and how I can bring that with me. But eventually, I think with all of this complexity, unless you're Richard Devine, who probably leaves that system patched in one way or another constantly, I think it's healthy to take a reset every now and again and just throw everything away.
A question for the modular synthesis approach. So you talked a bit about it, but I'm still wondering why you execute the code on the microcontroller and not on the computer. especially if you say one of the limitations is how fast it can be?
Yeah, so that's a great question. Two reasons mostly. So one of them is we wanted it to be scalable in the sense that if you just want to double your processing power, you just double the amount of modules that you have. So one of the other projects that I mentioned, as far as I understand, and if Alexandros is here and can correct me, please do so, but it's a controller module that hooks to the central Raspberry Pi in the case that runs everything. And if you add 2 or 3 or 4 or however many of them, they all just depend on that one Raspberry Pi to do the compute work. The reason of not using a laptop is because we don't want to be using laptops all that much in our everyday lives. And we thought it'd be fun to challenge ourselves to try and see how can we live code a sufficiently complex enough pattern and make sufficiently interesting music with a simple device like a smartphone or a tablet, for example. Sorry? Yeah, what's so different? So the one thing is the locality of it is a lot more portable. For the laptop, you need to find a space next to the modular usually, and if you're anything like me, desk space is a big premium, so it can be tricky to do that. With a tablet, one of our next steps is to try and mount that on the case itself. So you don't really need to move anywhere other than where your modular is, and then you can take that with you and so on. The other thing is that the touchscreen interface, again as a sort of limitation by design, will probably discourage you from typing a ton of code. So we want to get simple patterns, get complexity out of interaction of simple parts, and then send that to the modular and start playing as quickly as possible without having to spend 10 minutes building up some block of code. And performance for sequencing specifically is not a big issue. We're not doing audio rate DSP. We can get away with a €5 microcontroller, and it works sufficiently well for our purposes.
Okay, we must wrap the session up so that everybody has a break before the next paper session, but all the presenters are still here. First of all, round of applause again for everybody. And of course, also all the papers are available in the catalog to read, and we meet sorry? Sorry. Yeah, we see each other here in 10 minutes. So grab a coffee.
Thank you. Thanks.
So hello again. Welcome to this last paper session. This session is going to be dedicated about social implications and education. And so let's welcome Giovanni Mori, Giovanni Nulli, and Francesco Corvi. They are presenting live coding and education, a practical experience.
Good morning, everybody. I'm Giovanni Nulli. I'm from Indire, that is a national research center in Italy that work with schools. We are a public institutions linked with the Ministry of Education and the research center. We have the idea to implement a project into schools with live coding, and we search for partners at the beginning to improve our backgrounds. So we create a partnership with Tempo Reale, and then for the project we build a tender to select a live coder to help teachers to improve their coding ability. We decide to work with live coding inside the music curriculum. In Italy, music curriculum is music curriculum is just part of the middle schools. there is no music. I mean, there's nominal music into the primary school, but usually it's very hard that you have a teacher that is able to teach music. So the expert music teachers are just from students' age that is begin 11 and 14. There is secondary schools that are specific for music, the Music Lyceum, but we consider that for too few students. So we decided to try to implement live coding into music curriculum of secondary school. We want to try to understand as a research question if the curriculum as it is right for this kind of activity, and which could be the teachers' skills to have to be able to use live coding with students. We proposed this activity to 5 different teachers. Some of them has some live coding experience. The other are at least able. They are very good with the technology. And then we decided to ask them which kind of training they need to use live coding in classroom. We create a group with all 3 of us, and then we ask them to produce lessons with live coding. So we are not providing examples; we're providing trainings in music and coding. And they discuss with us how to consider how to create lessons into their normal course. This first year we meet at least once a week to have training and to have discussions, briefings, and if something will happen that we need to discuss with them, we select these issues or idea, and we have focus groups to point which solution for the issues and how to implement the ideas. We work in live research mode, and we ask the teacher to, let me say, in a active pedagogy into an active pedagogy paradigm. So they make students play. These teachers are, even before live coding experiment, very motivated into this paradigm. So they were both technologically prepared and motivated to let the student play. I underline this because not all the music teachers have this approach to the music into the schools. So some of them has a more, let me say, theoretical approach. So there are some base that are important for us to lead live coding into classes, and this is one of it. So a teacher need to let the student play, to let the students explore both physical and technological instruments.
So when everything started, about 3 years ago maybe, yeah, if I remember well, we thought what live coding can bring to school as an approach, as a discipline, and we started to think about this concept, and after a bit we realized that live coding can be a good tool to use for teaching many different subjects. In fact, if you think about live coding, the first thing that comes to your mind maybe is a tool to make music with code. So it just from this first thinking, you can involve music and technology together. But if you dig a bit under the surface, you can also see that live coding is not just music, or for the main part of live coding, for sure, but music and code, but is also mathematics, for example, is also improvisation, is also in some way civic education, because as the community promotes, it promotes equality, it promotes an horizontal approach to technology, etc. So by using live coding in schools, we can teach many subjects altogether. And on top of all these subjects are taught by having fun, because live coding is an involving activity and fun activity. So we thought that by having fun, students can learn easily and not without effort, but with less effort, some subjects that sometimes are hard to teach, especially in middle schools. So, for example, maths is very hard for students in general. And by turning around the problem with live coding, maybe we thought that it can be a good thing. After a bit of thinking and a bit of exploration, we thought that Sonic Pi was the best tool to use for this project for some main reasons. The first of all is that some of the professors that were involved in this project already knew the software. So for them, it was easy to learn Sonic Pi and then transmit the knowledge to their students. Additionally, Sonic Pi is also very easy to learn. So it has a very steep learning curve. And also for adults that, they are quite accustomed to technology, but maybe not very much with coding. So thanks to the simplicity of syntaxes, simplicity of reading the code, etc., they can learn Sonic Pi and live coding very quickly, and then transmit their knowledge to the students. Additionally, Sonic Pi is multi-platform, so you can have a Windows computer, a Mac computer, a Linux computer, and you can install it in each machine you have. So, and it's free. So this is a good thing, especially in Italian school without many funds. And additionally, Sonic Pi has also a very lively teacher community. So they have, there is a forum online where teachers from all around the world discuss some things about live coding and teaching live coding. So our teacher can enter in this community and discuss deeply the subject with them. And so we contacted, we selected, no, maybe we as a group, we decided to build a course for teacher on Sonic Pi, as Francesco will describe.
Hey. Yeah, so I'm Francesco, and I basically help the... it's off?
Yeah.
Okay, then. Okay. So basically the course for the teacher was online. We met once a week, and also to that I gave some individual support to the various teachers, because each of them had some specific things they wanted to try. And also we used a group chat to also create this feeling of making this project together. So the main point of this course, it was not really a course on Sonic Pi, but rather like Sonic Pi was the mean to address certain kind of topics involving mainly algorithmic music and improvisation in live coding. Also, it was very interesting to see how many things came up in discussion we did together. So at the beginning I presented kind of an idea of the topics I wanted to address during the course, but the main point was that the structure needed to be very flexible, because on the way we figure out a lot of problems that would have arisen in the class. And so myself, I am a live coder. I've been doing live coding for a while, but my main background is in the arts, in music. So for this reason, I think I could kind of understood which were the necessities of the teachers, and the main way I tried to introduce the concept was to translate musical concept into programming concepts. So for example, if I had to explain how I can use an array, I would say like, okay, think about a chord. A chord is a collection of notes. Those notes are actually numbers. And so in this way, you could rely on some kind of prior knowledge the teacher has, and by explaining what, for example, an array is, we are also immediately kind of pointing out some kind of applications of how that can be practically used in the program. So we kind of can divide the course into two phases. It was not like intentional, this split, but it's just something that I noticed more a posteriori. And the first part was mainly a bit more frontal, in the sense that I was trying to really give to all the teachers the same, because some of them already had some experience, others not. And so it was an introduction to live coding in general. Really, I showed like various tools. I showed various artists that are doing live coding in different ways. And then we get into Sonic Pi, so the interface and all this stuff. And then the first part was like introducing the various abstraction in Sonic Pi, so starting really like from a variable, a loop, then introducing the various data types that we have, introducing randomization, time states to start to like synchronize different loops. So I was trying to incrementally give an overview. All of these things, the lessons were kind of I don't know, half an hour, 40 minutes of explanations, and then I was sharing with them some examples of how to use these things. So this part somehow turned to be more theoretical in a way, or let's say more focused on the programming part and on the musical application of those things. In this sense, the music was seen as an application of what we can do with the software. And so kind of the last topic was how to write custom functions, and to that point we have a discussion, everyone, and we realized that probably getting deeper and deeper on the programming was not the best thing to do. And so like the second part started that was way more focused on how to use this kind of abstraction to make something artistically. Also, I mean, not just to kind of say, okay, now I'm going to apply this function, but really, what do I want to do music-wise, and how I can combine this knowledge we developed together. And So the first step to do this was to give some exercises that were kind of very guided. Guided doesn't mean that there was like a specific requirement, but I don't know, an exercise could have been like, write an array, write 3 loops that iterate the array, try to make changes, what do you notice? So like explore, but at the same time giving some direction in the order of how to do this, because at the beginning you know this stuff, but you don't know where to start, and that was the main problem. And the other solution that proved to be very interesting was to push the teacher to do some collaborative composition by sharing between them snippets of code. So like just write a small code, share it with your with another teacher, and then that teacher continues the code and this kind of things. It was very helpful. And then, yeah, other parts that were covered were like sound effects. That was because the teachers were all musicians. They were quite good musicians, and they also had some, aside from the teaching, they were interested in live coding as an artistic practice. So sound effects, they were asking like, oh, how can we improve the quality of the sound, or these kind of things. So that was a nice thing to try out. Then also, by the end of the course, they got very curious about the possibilities also of other software. So I introduced a bit Hydra in one session, and then also like a teacher made an afternoon lab where they involved the kids in having more multimedia kind of experiences. So that was also very interesting. I can say that by the end of the course, I was not even really giving the lesson anymore, but it was just a brainstorming session where we were all together talking about the problems that we're facing in the class. And those were actually the most fruitful and important kind of meetings, because there is where we talked about this project, which, yeah, okay, that I'll leave it to the conclusion. I go on? Okay. So yeah, this brainstorming session were actually probably very useful for us to understand all how the project was going, and to also how to improve this thing. Go on, or? Yeah, so some of the challenge we faced in the class were lack of pre-existing knowledge by the students. So now we are talking about the challenge that the teacher faced in their activity. So the first was that when I had to teach to the teachers, they had a solid music background. So I could have this kind of conversion of their music knowledge into programming knowledge. But then when you teach to a kid, it doesn't have any musical, most of them, and any programming. So the risk is that instead of making your life easier, it just becomes overwhelming. The point is that you can try to introduce this concept, making small steps. Of course, the point is not, in a music class, the point is not to teach them how to code. The point is to teach music to them. So as also our main goal in this project is to have an interdisciplinary approach to coding, this could be solved if all the individual topics would include some kind of coding. Because at that point, then you don't have to explain in the music class what is a loop, because that's probably something you already know, because you're doing coding in various classes, and then you can benefit from these aspects. The other point was that introducing to like young creatives something like live coding, it means that as a teacher you get a ton of questions, and probably you're not prepared to that. So some of the teachers were not used to this. But actually these lead to be an interesting thing, because it means that the lessons become more collaborative, less frontal, and it also really empowers the kids, because they are like, they see that, you know, there is a problem, the teacher is there, oh, I don't know how to do this, let's figure out, and then you figure out together. And so you're telling them, you will find this kind of problems, and you don't have to be discouraged. You just go on and we will do it. And yeah, and the last thing was mainly practical, is that like new generations, they are not really so much used in using computers. They use smartphones way more. So not all of them had computers at home, for example. One way to deal with this, that we kind of thought about it, but then we didn't really go through it because we were already an advanced stage, was that you can use like a smartphone with a Bluetooth keyboard and have a browser base, for example. And okay, I think, yeah, these are some examples we had of codes written by kids. We are a bit short of time, so you just, yeah, you can add
from question.
Yeah, so just.
We are too short, but so we are short of time, so we need to stop.
Okay, yeah. I just, one word for the conclusion was like, so the idea for next year goal is to involve different teachers from other topics and to understand how the kids are actually benefiting from introducing live coding, and then it's how then coding can be a way to transfer knowledge between topics. So these are mainly the thing we want to address next year.
Thank you.
Thank you.
Thank you.
So thank you, guys. Just remember that at the end of the session, we're going to have the answers and questions and answers and discussions and so on. So hold on your questions for the next, for the end of the session. And next up is Alejandro Franco, who is going to present towards another transdiscipline, art, technoscience, and emancipation as promise and provocation for live coding.
What should I go with this one? So just unplug everything. Hi, everybody. Well, first of all, thanks to the ICLC team for this amazing conference. It's always very nice to be here talking about stuff. Now, this will be dense, this will be difficult, this will be also red, so prepare yourselves for a nice 20 minutes of me reading. And also, I might cough a lot. So I'm not going to die, don't worry, everything is fine. But if I actually die, I just want you to know that I die doing what I love the most, which is complaining about capitalism in front of a bunch of people. So all good. Thank you. Okay, so here we go. In this text, I deploy Nancy Fraser's theory of the triple movement to analyze and reimagine the field of techno-scientific art practice in general, but also apply to the particularities of live coding imagined community. I provide an analysis of actor network theory and techno-feminist philosophical frameworks for the intention to reveal ideological blind spots introduced to live coding via these frameworks that obscure the political dimensions of the practice and its community building aspirations. I first take a detour to briefly explain the impact of such blind spots in a concrete community, namely Mexican live coding scene. And I then conclude this paper by applying the triple movement framework to a segment of the last chapter of the recently published live coding's user manual, hoping to supplement it with a Marxist feminist framework. So, slide 2. Okay, so we have to start by understanding what the double movement is. So the double movement theory was first proposed by sociologist Karl Polanyi, and it refers to the historical pattern of capitalist societies in which social institutions such as healthcare and housing become commodified by the market, leading to a disembedding of the economy from society. As a response, struggles to re-embed the economy in society emerge through the creation of social protection, such as subsidized social programs, labor laws, and taxes. This creates a double movement between marketization and social protection. So what is important to understand here is that the economy is disembedded from society and then re-embedded again. And this is like a loop that is unavoidable. Okay. However, Nancy Fraser argues that Polanyi's double movement theory is not deep enough to avoid the oppressive nature of re-embedding the economy in some societies, which can then adopt nationalistic, ethnic, and/or patriarchal politics like fascism, historically, and right-wing populism movements today. She argues that to avoid oppressive protection, a third dimension must be considered, and this one is emancipation. So that's how I particularly visualize the triple movement. I hope that helps. I am never sure. In the current political stage, movements towards emancipation are overly critical of state oppressive protection. Consider the following. The market, mimicking the grammar of emancipatory movements, co-opts them while commodifying society. Eventually, when the market crashes, people turn towards oppressive forms of institutional social protection, feeling hurt and upset by what they perceive as the failure of emancipatory movements, but in actuality it's the market that has failed. A clear example is anti-immigrant politics and some ideas that are put into people's minds about how, for example, housing becomes unaffordable because there's so many people coming in from outside Fortress Europe or from south of the border in the US, etc. So, Fraser's triple movement theory proposes a pattern that recognizes the market's cooptation power by integrating a Marxist critique of capitalism into emancipatory struggles and re-embedding the economy into society through emancipatory mobilization. So yeah, this is how Nancy Fraser supplements the double movement with emancipation as mediation. So, with this framework in mind, I will attempt to answer two questions in relationship to current forms of artistic and scientific transdisciplinarity tackled in the first part of this paper. What is the role of techno-scientific art and its ideologies, philosophies like actor network theory, techno-feminism, in relationship to the ongoing global struggles between marketization, social protection, and emancipation? And if we understand transdisciplinarity as a movement, how can we provide an emancipatory mediation between the arts and sciences that prevents the formation of both oppressive institutions as well as market-driven industries? So, first let's tackle Latour. Now, the focus is on discussing actor network theory and its implications, as well as the need for a Marxist critique in feminist theory to protect it from marketization. The actor network theory challenges the nature-culture divide and emphasizes the neutral and infinite connections between culture and nature. It suggests that the mere act of observation affects the objects of the experiment, making it impossible to distinguish between what is culture and what is nature. As such, culture and nature are always intertwined. However, as Lawson argues, actor network theory can be critiqued for failing as a political framework because it conceptualizes mediation as politically neutral, thereby ignoring the oppressive structures that shape society. Marxist, feminist, anti-fascist, and decolonial mediations can help us see how networks perpetuate an invisibilized market or an oppressive institution. In the case of the art science node, the industry, either the art market or the techno-industrial complex on the one hand, and academic traditions like post-positivist scientificism and or white Eurocentric art tradition on the other hand. Moving on to the case of techno-feminism. Technofeminism acts as a monist emancipatory mediation between market and society. However, because of technofeminism's root in post-materiality, it lacks the historic materialist class critique necessary to avoid being captured by market forces. As Cotter argues, new materialist feminism naturalizes the market and women's exploitation by capitalism and invisibilizes class relations. Therefore, it is essential to integrate a Marxist critique to protect feminist theory from coupling its emancipation to marketization. As Fraser argues, the pressing task for feminism today is reconnecting struggles against personalized subjection to the critique of a capitalist system that, while promising liberation, actually imposes a new mode of domination. Now, I am... Wait. Yeah, we're still there. Okay. Ultimately, for both technoscientific art and technofeminism, if they neglect the power of Marxist critique and class struggle, their emancipation runs the risk of multiplying neoliberal subjectivity and techno-feudal dominance. The science art practice offered by Bruno Latour and also via Latourian frameworks falls back into the loop of marketization and oppressive protection. Technofeminism separates feminism from class struggle, avoiding oppressive protection but deepening marketization. I will now use the triple movement theory and take further the critics to actor network theory and technofeminism to understand certain particularities of the Mexican community of live coding. So now, yes, there. Okay, so there was a very big and transformative revolution in Mexico between 1910 and 1930. It almost broke hegemony, but it just didn't. But at the end of this revolution, a form of social protection emerged. And with time, and key in this timeline, the 68, Mexican 68, this social protection became oppressive. It became an oppressive form of social protection, unambiguously. This went on until the 80s, where an emancipatory force that we are calling right now democracy emerged and challenged this oppressive form of social protection. Ran for elections and failed to grab power because of election fraud. So, context. Then, neoliberal forces took power in 1988's election. And in an attempt to appear democratic and transformative, co-opting the grammar of emancipation, established the National Council for Culture and Arts, CONACULTA, and the National Fund for Culture and Arts, FONCA. However, according to Tomás Egea, these institutions only reified a power structure where a wealthy minority dominated, while the rest had to compete for resources. To give you an idea, according to this guy's research, 10% of FONCA beneficiaries hoard 50% of the benefits of FONCA, while 90% has to fight to, for the leftovers, basically. No? So, the fragile neoliberal order broke around 2015. There are many reasons for this. The international ones, perhaps you know, like Trumpism, Brexit, etc. But more particularly in Mexico, insane race on violence, which led to finding of extermination fields in the north of Mexico, concentration fields, extermination camps, concentration camps, etc., which just broke hegemony completely. The neoliberal order was in crisis, and there was no way of anybody believing anything that could be said on the name of neoliberalism. So, right now, the current political moment is marked by a crisis of hegemony, with a move away from dominance of neoliberal marketization towards a new kind of social protection. In the context of in this context, our art practice is being reimagined to fit this protective attempt, but it is met with fierce critical positions emerging from emancipatory movements, such as feminisms, multiple feminisms, decolonialism, and open source software, which I will focus a little bit more since open source software is like somehow close to live coding. Oh, I'm still in the right slide, so all good. Okay. While Mexican communities that relate with open source software principles and live coding in particular provide infrastructure and spaces for new social bonds, resisting state-sponsored art creation institutions, and fortifying emancipatory mobilizations, they remain vulnerable to marketization. The reason why Mexican live coding remains open to a market-oriented escape from the current crisis has a double source: the pervasiveness of state politics in tandem with the lack of Marxist class analysis normalized in the transnational, aka the global north, academic and artistic environment. For instance, open source is deemed often as quite political, but actually somehow politically agnostic, because at the same time that it can provide us, like us in live coding, a framework to share ideas, to share material means, etc. It also allows a space for big corporations to experiment or to bypass legal frameworks that protect people from their predation. So open source can either work for some or for other people, no? Live coding openly embraces open source software's ethos. It also remains open to technofeminism and actor network theory as frameworks from which they have weaved ideological positions useful for the dissemination of live coding as a transnational project. It is worth interrogating the ways in which these ideological frameworks also introduce the aspects here critiqued, the neutral and monist connections of Latourian frameworks and technofeminism, into live coding when they are used as a social theory to explain its own community building processes. So next slide. So this beautiful wall of text is a bunch of questions that perhaps people in the Mexican live coding community could relate to and could, think about or something. The questions that require further research in an environment like Mexico's electronic art scene are: which artists are successful in this context? Which art is recognized as rewarded with grants and prizes from the market? Can art that critiques the market flourish in this scenario? Moreover, what happens to the artists that can be integrated into neither the market nor the state apparatus? When no theoretical framework can explain the precarity or frank poverty of artists, what affects are engendered and what is the responsibility of well-established artists facing this situation? How can successful artists avoid stigmatizing artists that are perceived as angry because of unequal wealth redistribution? Will the artworks of techno-scientific orientation communicate the audience a co-opted form of emancipation? And finally, does technology in live coding settings appear as a self-serving tool for artists and researchers to build careers and to be complicit in capital accumulation? So, okay, that. I will now talk about the recently published user's manual for live coding, edited by MIT Press, and also there's an experimental version of it that has been unleashed in GitLab, which is a pretty interesting way of publishing a book. In particular, I will focus on the last chapter that describes what live coding wants. I like this, that live coding desires things, no? And moves through desire. I will focus on the, I already said that. In this segment, the authors give an explicit political orientation to live coding while also distancing themselves from another political framework. So, the true spirit of the left is not to be found in a socialist state, but in the liberty of playful expression. The play of making new rules, new algorithms, and new structures is indeed a technological speech act, but one that brings into existence new kinds of social relations, as well as human-machine relations. So this is a very interesting segment, And I wonder what the triple movement has to say and can say about it. Okay? So, sorry, I just got lost in my script. Now, we need to approach the distinction of anarchism and socialism proposed in this segment. Freedom, as implied in this text, is assumed to be a movement away from social protection, here understood as the structural violence apparently inherent to the socialist state. Perhaps, as a first attempt to make sense of this snippet, I will formulate it from a Deleuzian Guattarian perspective, which calls for a playful experiment as an escape from overly codified social conventions. This process could be described as deterritorialization. It's always followed by reterritorialization. So, yeah. In other words, the game for assemblage theory, the Deleuzian-Guattarian frameworks, is to permanently be one step ahead of the abilities of capitalism to reabsorb the energy liberated by the lines of flight. Such processes must be faster than capitalism's digestive capabilities. Faramelli, drawing from Zapatismo, amends assemblage theory and calls for a slow and constant deterritorialization, rather than an accelerated one. Thus, a fundamental question we should ask for live coding is whether the playful expression of live coding is slow and constant, or if it participates and enables the speed of capitalism. The process of deterritorialization that the playful expression of live coding favors appears as the locus of liberation. However, the movements between deterritorialization and reterritorialization must be understood as a necessary feedback loop to transform social structures and processes mediated by emancipation. In this way, the playful expression of live coding ineluctably occurs followed and or preceded by a form of social protection or marketization. Oh. Yeah, okay, I will leave it there, why not? If the loop between social protection and emancipation is inescapable, the question of the commons via anarchism or socialism is inadequate. What is relevant is to orient ourselves towards the processes of emancipatory mobilization interplaying with structures of social protection, regardless of an anarchist or socialist framework. I suggest that the political potential of live coding is something yet to be explored that is irreducible to neither anarchism nor socialism. Finally, perfect, just in time. Finally, it is worth interrogating if live coding practice can anticipate post-capitalist modes of production by aligning to an anarchist spirit, or perhaps points to the dialectic transformation of anarchism and socialism that makes them both commensurable as political turbulence. Instead of favoring one ideological stance, live coding has the potential to transform both by acknowledging the need for dynamic political processes and structures. To conclude, the playful expression of live coding as a form of research and art creation can be a powerful tool for emancipation, but it must be mindful of the feedback loop here traced, the movements between social protection, marketization, and emancipation. Thank you. Thank you.
Gracias, Alejandro. Thank you so much, Alejandro. So for the last presentation, but not least, we're having Alex McLean and Julian Rohuber. So with the meaning of life, from art without audience to programs without users. Thank you.
Thank you, Lina, and thank you to all the organizers and all the people making this happen. It's been lovely already.
Is that good? Like that? You don't have to bend down. Okay. Yes, so we'll try to have a dialogue a little bit on some very, very simple things that everybody knows, so nothing new, only old stuff. But just to kind of start a discourse on things that one easily forgets and that go back to the early stages of live coding. We do this talk actually as three persons. One person is here, but you don't see her, Renate Wieser, who has written also the paper with us. She couldn't come, unfortunately, so we hope you keep her in mind. The black slide is very important. So this is just the kind of a skeleton of the paper, but it's backwards. So the paper is in the other way around. So if don't worry if you don't recognize it, it's backward. So I think the starting point was, like, we both were a bit unhappy about a certain reception of live coding in the computer science community, or maybe more in the software engineering community, maybe one could say, where it's kind of said, oh, well, live coding, it's always been there, that's nothing new. And on the other hand, it's live, what we call live programming, and artists do something strange, actually, right?
Yeah, they call themselves live programmers explicitly to separate themselves from the live coding community. Even though we've kind of used live programming, live coding interchangeably, we've kind of settled on live coding, and so this other community of people who call themselves programming language experience designers or the future of coding, they kind of tend to call themselves live programmers, but at the same time sort of occupy the same kind of territory, use the same kind of references, look very similar, but there's something very different about it.
And what is the interesting thing about that, I think, is that through looking at that, one can kind of carve out what is special about live coding, what was actually a new step, although of course it has its prehistory, but where live coding was a turn, actually, where it turned. We can make it a little bit more precise, I think, by looking at that. Let's go one, just comment that one thing. So I mean, the whole point about software engineering and live programming is to make this work, this labor of making an application more efficient, right? I mean, it's a lot of work, and we see a lot of other work done towards that with auto-completion basically of code, or automating software writing. This goes back in the history of programming language to programming itself, which is originally was automatic programming. So it's about making this process more efficient, but in the end you always have an application that is then used, right? So that is kind of the strong thing that where you need this interactivity, because it's very hard to imagine what a user wants. You know, you have to parameterize out what would the interactions be and all that, right? So this is a difficult work. So you need interaction. So you integrate this kind of interaction into the development environment. Right?
But the word efficiency already implies that you have something you want to do, and you want to do it as fast as possible. So it's like beaming your ideas into the computer, and the aim is to make it really seamless. The kind of end game being to have a Neuralink device plugged into your brain and just download the code into the computer. And so kind of the aim, if this is what you want to do, is to remove programming and just make it about pure expression from your genius ideas channeling from the heavens into the computer.
So strangely enough, live coding is not about that, obviously, right? I mean, I guess for everyone here who knows live coding, it's obvious, it's totally obvious that's not about this, but there's this presence of the activity of programming somehow there, right? Which is irreducible.
You're not trying to make things efficient, because then you'd finish your performance really quickly. And at the end of the performance, you might delete all your code, and that's not very efficient thing to spend like half an hour working on something and then delete it. It's yeah. So yeah, it's something quite a different activity.
So should we?
Yeah, let's check our notes. Yeah, I think we.
On what slide are we?
This one.
This one. Okay. Yeah. Okay. So yeah, this activity of thinking about a later application where you need to think about what will be the interaction in the future is. I mean, if it's there in live coding, it's very local to this one process, but it's not delegated to a later application where you have to think, okay, there's going to be a slider for this, you know, like you don't need, I mean, the very simple thing is you don't have a graphical user interface you have to design and then use. That's, of course, one of the first steps. And that is maybe the simplest example of a deeper thing about not having an application.
Yeah. Yeah, the code becomes a kind of, with live coding, the code becomes a kind of interface to yourself because you're kind of trying things out, asking the question, what if I do this? What happens to me through this kind of unfolding of the code, these in this kind of unpredictable yet deterministic structure that makes these patterns or whatever, and then you experience it, see what that code does to you, what it means, and then that informs your next question, what do I do next? Yeah.
So, but what's the point? So where's the difference now? I mean, apart from that simple fact, right? So what we found that there are actually two meanings of life, or there are actually more, but let's... So one kind of liveness in the program. I mean, there are very general two meanings of life, which we can find as epitomized or as realized in a technological or in the programming world. So the live programming or I don't want to actually use that word because it's also live programming. I don't like the difference between coding and programming. Terminologically, this is really stupid. Like, I think, you know, this one kind of life is when you embed the runtime process into your programming environment to make application building more efficient, right? So this is the one side. And the other kind of liveness is to make the programming part of the runtime process, right? Where the program itself cannot really run as specified without being programmed. So if you take a bit of a live coding patch and run it, and then wait, then the program runs incorrectly. It needs to be reprogrammed. So that's the difference, and that's also what is very hard to explain sometimes. Because if you do this kind of, if you have this imagination of being someone who designs applications only, right? I mean, everyone needs to design application once in a while, but that's not what live coding is about, right? So, so there's a division of labor between the users and developers, and even in cases of end-user programming, which we had today, I think there's still left, I mean, it's very close, but there's still left this aspect of getting things done. So you want to, integrate programming to make the task more flexibly being solved, and in the end you have your Excel spreadsheet correct, right? And then it's done. It's, you know, it's still this aspect, but it is a spectrum, you know? It's not completely black and white.
Right. Yeah, somehow when you talk to software engineers about this, this idea of using code in this way is seen, I think it's something that all programmers do through REPLs and things, command lines, but it's seen as a marginal activity. So bringing out the possibility of evaluating code in an editor framework with a software engineer, they said, oh no, evaluation is just for utility. So in a way they were saying, oh no, that's only for use, that's not anything valuable, just use. And so there's just like a strange disconnect between what we're trying to do, which is to use code in order to, as part of a making process where the code is sort of woven into that, is just seen as marginal things where you're just making use of it, as if that has no value. If you as a programmer are using it, that's not part of the actual outcome.
Yeah, and in a way, that's pretty obvious.
Yeah.
I mean, it's telling nothing new. And in a sense, we thought about like it for the beginning of live coding, that also wasn't such an unobvious thing, right? It was not so so unobvious. I mean, I was always surprised how hard it was to explain to even like really knowledgeable people who I adore for their abilities. They just didn't get the point, and it was very hard to explain. And the question is why? So why did it appear in the art context? So in the 1990s, one can say that there was some basic agreement about that something about like live coding would make sense, I think. But it's in the art community, and it was a critique of software as a commodity, and also of art as a commodity, right? That was very strong at that time, and that was basically comes very clear in the Hamburg data art movement, which took place or was connected to the Chaos Computer Club movement, and the 10th Chaos Computer Congress, where Kurt Alsleben and Antje Eske were presenting things. And here's an example, just to give one point, how they formulated that. This was, when I studied, that was the first diagram I saw on a publication that was laying around. It's called the 3-3 schema, and it's kind of strange. And it tries to explain different relationships between people who do things and people who watch things, right? And between art and audience. And the kind of the rightmost is this classical performance thing, right? You have performer on a stage and an audience watching it, and you can see that liveness in that sense of distribution liveness has something to do with this image. Like live broadcast TV, like you have a camera and you can broadcast it live to many, many different audiences and people. It's about distribution. And the left one is what they call Verkehr, which is exchange, German for exchange or something like that in that context. And there this audience is dotted, so it's just accidental. Can happen that someone watches it, but it's inessential. Right? I mean, it's also something everybody knows, right? It's not, but it's interesting to put it out front and say there is something that is art without audience, Kunst ohne Publikum, they called it, and it happens in this semi-official space. I read it out. This semi-official space is a place that makes exchange possible. Data art, net art is art without audience. There's nothing to be offered. No sender addresses a receiver, right? So they come from information theory with this the whole cybernetic thing in the background, and they say, no, I mean, it's not a transmission as such. And so you have all these genres at that time that still exist, of course: participatory art, net art, meta art. Artistic research is more now, I think, which kind of goes into this, which sees the audience not as the main addressing part. Oh, I don't know what comes next, actually. Ah, yeah, right, changing grammars. Yeah, when we organized Changing Grammars, Renate and me, and we all met for the first time, it was at that place where Antje Eske and Kurt Alslim were working, and it was obvious that an audience is not necessary. That was kind of bottom line. And you can trace back some ideas of live coding to that, I think. In retrospect, I have to say, because I never thought about it, honestly. But it's so obvious that I didn't think about it. But sharing screens, for example, was not in the initial moment like for an audience as such, but to share a space. Even, I think, for you in the clubs, it was about sharing a practice.
Yeah, making visible, sharing the making process.
And so programming as ongoing thing was also about not producing a product and showing how best to produce the product, but about doing that process together. And we had this seminar called Zuschauen, Entspannen, Programmieren, Watch, Relax, and Program, which projects code on the screen, and people would sit and have this receptive attitude and just comment, and maybe one programs a bit more and one listens a bit. So it had this spirit, kind of.
Yeah, I think there's something important about sharing screens because it becomes like an oral practice then, becomes visible as an oral practice, in that you're not recording things necessarily, you're not writing code and then releasing it. It's much more writing code for the moment. And without sharing the screens, that's not visible and it's lost, it loses value. And I think this is a problem with oral culture in general. It has so many, there's trade-offs, but it has so many plus points. By oral culture, I mean not written down, which is strange to talk about with code because it is obviously written. But yeah, with actually making it visible, you can't really give it power to continue as a practice. You need to share it. If written scores have so much power and have overtaken so many oral cultures, simply because they're written down, they have presence after the fact. But if we share it during the fact, then we kind of regain territory and create space.
I guess, right. This showing has this emancipatory aspect, like in the Freeman movement and the French education reform movements, where they show children how to make books, for example, in the early 20th century, and so the kids lose the respect for the book, right? They see a book is being made, and it can be changed in principle. So to project something means, and to have access to it in discussion or directly, you see that a rule is made and can be experimented with, but it can also be changed. So you think about conventions and so on, and think about also consequences. I mean, you start a rule and then you play with it for a while, right? So it's not about being, because we have this tension between anarchism and socialism, or like rule and anti-rule. I think that was very, very good. And this dialectics can be directly played out in code in a way, or in actions and so on, in rules.
Becomes a form of speech.
So these always forgotten ideas, they're always there, but they're easily like swept away. I don't know, somehow. That there exists art without audience. It's very normal for all artists. It usually exists in their studio, things that they don't show, or they show only each other, not the audience, right? Or also there is art without audience, like kind of a practice. And there are always programs without users, but it's something to cultivate. And so that's the meaning of life, I guess.
Thank you, Bob. So now it's time for questions, finally. So if you have a question, please come here so we can share with the people in the streaming. Thank you.
Request from the stream technicians. It seems that we've been hogging the Wi-Fi, so if you don't actually use it, please log off.
Thank you, Luca. Any questions? Can you come here, please?
Well, I refer to the last talk, and
Would you not stand in front of the speaker?
yes, I can. I don't want to take this space here. So anyway, I thought that was very remarkable to see exactly you both that are from the beginning of this movement. That it's also nothing new. That was pointed out so much. Nothing new. That these are the two authors of the most popular used frameworks in live coding today, like Chitlib still, Super Collider, and Tidal Cycles. I can say that because we had just examined the 10th birthday, and it was pretty obvious these two frameworks. We don't call it applications, but it's not so easy to not call it applications. So you have users. And you are the authors that talk about being reminded that programming is the activity of programming is the actual point. Now I see that what has been created, and I thought that was pretty obvious. It's a lot about our engineering topics that you pointed out yourself. So how we get to better live coding practices, how we can improve it. It's about brevity, it's about conciseness, it's about speed of altering code. So I'm not so sure if there is not, what is a program, ontological difference even between live programming and live coding. What I see here has becoming a lot about live coding, but not so much about live programming that you reminded us to think again, to always forgotten questions. So you have users, and you both the most of all here. So that's my question. How do you deal with that? I mean, you didn't address that, and that's particularly interesting.
Our users are not users; they are developers. If you wanted to use it in this, no, that's the point. I think we write languages not to have users.
Yeah. Yeah, it's a tricky one. Yeah, I guess it's nice to not draw the distinction as much as possible, not to have a core team of developers working for other people, not to encourage feature requests, but to encourage people to share ideas that aren't requests, but more like discussions. I think there's different ways of making a community or making space for a community that kind of undermines this normal distinction between user and developer. I quite like the word janitor in terms of tidying up more than kind of developing something for other people. I think when you're running a workshop, teaching people, you learn so much. So it's always like a two-way exchange, always seeing new ways of looking at your software. So yeah, it's nice to kind of break down this distinction.
There was another question before you, Marije, sorry. Shelley was first, I think.
Hi. Yeah, I had a question for the first speakers, Giovanni, and Francesco.
Okay.
You said at the start of your talk that you were interested in how to introduce live coding in schools in an inclusive way. And I just wondered how you're defining and evaluating inclusive, and if there were any particular methods or approaches that you found that were particularly useful for developing inclusive teaching.
Well, we use the word inclusive because a lot of teachers, when we proposed that kind of activities, said that it could be useful for an afternoon lab. Instead, we asked for a curricular space into the lessons. That because often could happen that the afternoon labs are for students that has family more aware about this kind of activities. So we think that the curricular time and space is more inclusive. Then could you repeat the question? My memory is not so... Okay. Okay. Before evaluate, we asked the teacher in which way they consider that kind of activity. That it means that we have mainly two ways to consider that kind of activity. The one is a new way to explain something that is already part of musical curriculum. The other one is this is an instrument to play with. They are not so separate, but mainly there were these two different ways to consider that activity. The first way was evaluated, let me say, in a traditional way. So they study some part of music and in a different way, but it is evaluated in how the students learned that part of the music curriculum. The second part is a more executive way, and the evaluation was done between students. I mean, let me say, if the pieces, the music is the student like the other student like the music, and then the teacher evaluated from the he say to produce a piece of music that should have some characteristics. Then he evaluated how much this music, the code produced by the students, match with the teacher ask, the teacher question to the students. I don't know if I was clear. Sorry, my English sometimes is not so good. Okay, and we had the problem that the teachers asked themselves and to one of the groups if they should in some way evaluate the algorithmic part. The group decided that this is not necessary. I mean, first of all, because they are music teacher into the music curriculum. Second, because they felt not confident to do that. And how to evaluate an algorithm that was used for music. I mean, they said, they proposed to evaluate if the algorithm is more synthetic than another, but it's not a music characteristic. So they didn't want to do that, and we consider that this is not, I mean, useful for music curriculum. Okay. Oh, sorry.
Sorry to interrupt.
Maybe.
Yeah. So I think we have a queue of questions here. So let's continue with that.
Well, the queue can grow. The question is, can they then all be served? Thanks all for the very interesting talks. I had a sort of question or maybe something to reflect on for the last talk, because
yeah, at the start you were talking about how programmers who are working in maybe engineering or in business. I agree that it's always about efficiency. That they want to make code that is very efficient. But at the same time, I see that development cycles, especially for web-based use of code, has become really fast and could almost be seen as live. I know from people who work in that sector that actually, when they expect a lot of visitors, they enable and disable certain parts of the code so the machines don't get overrun. And I think in that case, I actually also I wouldn't see the visitors to the website as users, but rather as participants in the business model. In that the actual people who are really sort of using the code are the developers themselves, who continuously evaluate if the code they wrote is serving the purpose, if the costs of writing the code balances the profits made with the code. So I thought maybe you can reflect a little bit on those aspects, because I think there's a lot of sort of live programming and maybe almost live coding happening there, with of course a completely different capitalist purpose.
Yeah, I think, in the paper we talk a bit about DJs as an example, and I think what you're talking about here is liveness, but also control, about whether you have these consumers who you're trying to control to extract the most money from by, being as live as possible, I suppose. And you can say the same as DJs. They have the role as someone who's controlling the crowd, or you can see them as creating space for the crowd, giving them a story, or responding to them. And so, you can say that's live, but it's live for a different purpose. You're not inviting people into your development process. You're developing things as quickly as possible in order to control them. So it's interesting how live coding and DJing sort of move together. And these different ways of approaching DJing also, it's an interesting way of then looking at live coding, not saying that one is better than the other, but saying there's these different kinds of live DJing, a whole discourse around them much older than live coding, and we can apply that to that.
Yeah, it's good that you mentioned the dark side of live coding.
Yeah.
No, I mean, this is kind of participation is an ambiguous thing, right? Making people participate can be very oppressive, and it can be very liberating. So it's neutral in that way.
Yeah. So we are kind of short of time, but let's see if the answers are. So let's go. Two more,
maybe.
Sorry about that. If you want to ask.
Okay, just a quick reflection. We have been discussing that on the importance of the community, and the community being something that is not mentioned in the manifesto, for example. And this idea of community and where live coding being a just-in-time activity and maybe a community, activity in a practice in a community that the audience disappears, is that the place that where live coding can be positioned in a way that it actually can escape this capitalistic rush of productivity that Alejandro and you, in a way, were talking about? Is that something we would like to? Anyone wants to comment on that? Is that the key point? Is that the meaning of escaping capitalism? Is that the meaning of life?
I think that the key is to understand this dynamically. Something at some point might be, I feel that I'm provoking a weird feedback loop here. Something that at one point can be emancipatory, liberating, at another point cannot be. I guess the thing is that there are concrete situations, and these concrete situations need abstractions for pedagogical purposes or for purposes of understanding, like epistemological purposes, etc. The thing with abstractions is that if you don't, do the concrete abstract and then concrete back again, they sort of remain like floating there as fixed entities, right? I think that, just something that can be liberating at this point, if evaluated in another concrete situation, cannot be, no? And I guess that's the key, no? I do think that what Julian and Alex are pointing towards, of course, no? But I guess like the point that I'm trying to make is that there's always like, we always have to be analytical about it, no? And we always have to understand the whole context around a particular situation to understand it better. That works for you? Yeah, cool.
No, that's fine.
Okay, so I'm sorry about that, but I need to wrap up this session. But you are gonna be there, I think, for the lunch, so we can just keep going with the discussion outside with the lunch. And we also invite you to the next concert, which is like 10 minutes. It's going to be a concert in 10 minutes with Niklas Reppel and Monique Cooper, so just rush with the...
just wait a little bit before all the other people in the back are also entering and taking a seat. But in the meantime, I will very briefly introduce Marije Baalman from my personal perspective. I think I started becoming interested in creative coding and open source communities maybe like 12 years ago. I was doing this master's program called New Media Art and Digital Culture. And then I started interviewing, I think like 21 people around this crossover between art and science and the influence of open source communities. And one of the first people I interviewed was Marije, actually. So I don't know how long this is ago. But yeah, it was really nice, and actually one of the inspirations here also for me to start Creative Coding Utrecht and start creating communities. And so this is a bit my personal history with Marije. And of course I still remember the Algorave in 2013 where you front row dancing.
2014, yeah.
Yeah. So I'll leave it with that. Maybe the second sub-theme of the displacement is about human-machine entanglement, and this is Marije's topic, where she will dive into. Take it away.
Thanks, Fabian. So, first of all, I want to thank Creative Coding Utrecht for inviting me and also organizing this conference. I think I heard from Philippe that this was coming up at some point, and he asked me whether I wanted to be part of it. I was like, that's a lot of work. I don't think I have time for it. So a big thank you for all the people involved to making this happen. I've been around the projection era of live coding roughly since the start. I think so I actually, even though I was not live coding myself yet at that time, but I still remember being at the ICMC in 2003 and where Gay Wang was presenting his first paper on Chuck. I remember the performances of PowerBooks Unplugged, which I found really inspired. I asked Julian whether there was a rebound tour coming up. Not yet. We still have to wait 10 years, I think. And I also vaguely remember a performance event at the Seabase in Berlin, I think during Transmediale, where also Craig Latta was performing. And this Swedish duo of Click Nielsen and Olsen. So I've seen a lot of live coding. I also remember really heated live coding battle between Gay Wang and Nick Collins in Madrid. No, Barcelona. I just remember the venue was really, really hot. It was, even to watch it, it was a performance. At the same time, I've also, I think, always been quite critical of live coding. I've been using code as an interface in a lot of my work. But actually the performances, live coding performances that I've made, I just looked back and there's like 4 performances really that I developed. In all of those I avoided to stand behind a big table to live code. I've been refusing this big black block on the stage. So I've always battled to get some space on the stage to move. So in all these performances I've also always reflected on the medium of live coding as well. So I'm really happy to share some thoughts with you in the coming hour or so. It should be a little bit less, but then we have some time for discussion. And I want to start with some thoughts that I developed for the first ICLC. I think back then I just watched back some videos from that. And I think we've settled on ICLC. I think then we were still wondering whether it was ICLC or something like that to pronounce this conference. I think it has settled now. I see Alex laughing, so I guess it has. So back at that conference I was talking about embodiment of code. So I'll start with some thinkers that have inspired me in my work about embodiment and technogenesis. So one is the book The Embodied Mind by Varela, Thompson and Roche. And they wrote, like, by using the term embodied we mean to highlight 2 points. First, that cognition depends upon the kinds of experience that come from having a body with various sensory motor capacities. And second, that these individual sensory motor capacities are themselves embedded in a more encompassing biological, psychological and cultural context. And then the second citation is from Catherine Hales. She's writing about digital technologies and our relationships and development in that. And she wrote, like, conceptualization is intimately tied in with implementation. Design decisions often have theoretical consequences. Algorithms embody reasoning, and navigation carries interpretive weight. So the humanities scholar, graphic designer, and programmer work best when they are in continuous and respectful communication with one another. So I'll just leave these quotes there, and they relate to what I'll be talking about. This is okay. So code is embodied by the human in that we adapt our minds to understand the language. And somehow the order got messed up. We adapt our vocabulary within the language to express our concepts. Then we extend the vocabulary or the language. And also very much our thinking is shaped by using the language. If you've written specific snippets of code quite often, those become part of your regular vocabulary. And also our typing skills are shaped by the language that we code in. And I have one example, one of my screencasts from my first live coding performance was watched a lot, and at some point on the Supercollider mailing list there was a discussion about the autocompletion in different editors. And someone was complaining that he'd seen this screencast and said, like, oh, the autocompletion in Scale, the Emacs interface editor for Supercollider is so slow. And I had to react and said, like, there was no autocompletion used there. So apparently I had embodied the code so much in my fingers that it was confused with automation of the machine. So But yeah, basically the idea is like the development of our live-coded concepts come out of this continuous dialogue between ourselves and the language, both during and in preparation of the performance. Then to the other, in the other direction, the code is also embodied by the machine. And this is also something I've been thinking out. With my dad, when he was still alive, I talked a lot also about what I was doing, and he had been in computers since the late 60s. So when we talked about live coding, he actually said, like, well, you can't actually really change the code that is running, because when it is sent, when it is at the CPU, you can't change it anymore. So he also inspired me to look up some papers on how early computers were designed. So the 1950s and 1980s, there were some other architectures, in particular the ones from Burroughs. They made these big mainframe computers, and the hardware for these computers was a lot more complex than those of their competitors, because they were designed based on the requirements of the programmers. So the hardware was adapted to accommodate concepts for programming, rather than the other way around, which was in the other types of architectures, where the programmers basically had to deal with the physical properties of the hardware design. And that's still, if you go to the lower levels, we're still using like these multiples of 8 bits for memory lengths, and that's really a decision that was made by hardware designers of these von Neumann-derived architectures, that this was the most useful way, and then we shaped our methods of programming around that. Of course, nowadays, programming languages that we are using, in particular also in live coding, are more and more abstracted from the hardware. But it's still interesting to think, like, okay, what could happen, what would have happened if we would be live coding on completely, like machines with a completely different architecture. So I want to highlight some works that deal with the physicality of the machine. One is 2 works from Jonathan Reuss. You see him here performing iMac music. What he's doing here, he's actually live hacking into iMacs while they are running code, and you see the projection of what's happening on the screen. So that's as live hacking or live coding as it can get in a hardware sense. Similarly, also in 2011, he had this work called Laptop Music, where he was also using electromagnetic coils to pick up the sounds and the electromagnetic waves that were going on within the laptop, as he was also processing algorithms to manipulate that sound. Also quite interesting is this screenshot from Beta Blocker from Dave Griffiths, which was a virtual 8-bit processor with 256 bytes of memory and a small instruction set. So to live code in this, it was really manipulating the program memory of this virtual machine, which resulted in these graphics and also sound. In my own performance, Code Live, this performance was actually prompted by a friend of mine who asked me to do a live coding performance, and I was like, okay, when does it actually make sense to live code? Because you can just play back the code and then it's the same thing. So I was sort of thinking about this, and I thought, okay, let's use just the input from the internal microphone as the input. So that's the main sound source that I then start to manipulate with the code. And then I was also using various other inputs, like the keyboard, touchpad, track point, that were in the computer, and also sensors, like in those times you had accelerometers who were monitoring how much you were shaking your hard drive, so they could be blocked and protected. And also the camera I use as a sensor to so the laptop also sees me moving. And so I was using these parameters also as controllers that I could then map to different parameters in the sound. Yeah, also quite important, I was performing this with actually the laptop on my lap. Not many people actually use it in that way. So we'll show a short video of that. This was a sort of remake I did in 2020 in the 10-minute live coding challenge organized by Creative Coding Utrecht. I had to hack around a little bit because all the code was not working on the laptop that I was using anymore. So, but you don't see that, so it's a screencast. So. So I will leave it at that. The full performance is online. You can find it through my website. So I want to go a bit deeper on these thoughts on code embodied by the human, or as you also could put it, thinking inside a system. So I made this diagram to sort of illustrate how what the usual setup is between the live coding that we do within a live coding language, for example, SuperCollider, which in itself is implemented in a language like C++, and that is compiled to machine code that runs on the CPU. I might forget a few layers, but this is roughly what's going on. And often within the live coding language, we've also created our own framework, for example, like creating classes, having developed our own dialect. So there's an additional layer there. Yeah, and this annotates the different connections between that. So I want to, and I think this was also in the previous session addressed a little bit about constraints and limitations. So I want to cite a chapter by Roro Berhal and de Campo in the SuperCollider book, where they wrote, like, in programming as in artistic activities in general, the need for constraints is at least as important as the desire for features. Limitations are themselves features that require implementation. And they also wrote a bit further in that chapter, wherever a program is not a black box, that is a closed system in which the user has access to only input and output, but an intermediate step in development or composition, the specific way in which a language is constructed makes some things easy to express and do and others harder. Thinking within a given language, some ideas may never occur. And I've highlighted the last part in blue because I think that's a very important aspect to think about, which not only in programming, but generally, like, our language influences a lot on what concepts we can even think about. I don't know, a lot of you hopefully speak multiple languages and sort of know, yeah, how some of the languages, you know, you can express certain feelings very well and certain concepts, and in other languages it's a lot harder to express those. They also, on the other hand, wrote there that computer languages not only intertwine process and description, doing and saying, but they also enable the construction of other languages or systems that in turn become the basis of new programs. And they elaborate on that with, if a program is something like a recipe for a cook, it resembles just as well a recipe for a recipe, or even a recipe for the construction of a cook. Yeah, I also want to, this also then goes to the creativity of the programmer. And back in 2001, I was at a symposium organized by Sonic Acts in Amsterdam called The Art of Programming, and they were discussing a lot about the role of coding and programming in the arts. And I had just started making electronic music, and I remember that Robert Henke was speaking there, and he was stressing to all of the people in the audience, who are mostly also artists, saying, like, yeah, it's really important that you write your own code and you develop your own code to make your music. Shortly after Ableton Live happened, similarly, I want to share this quote with you from an article in the Floss Plus Art book, where the author wrote, "This can lead to the bizarre situation where programmers make commercial software which practically generates music, and yet somehow the users of the software are seen as being more creative than the programmers. Here programmers encode their musical style in the software, and the users go little beyond guiding the software to a destination pleasing to them. This can be seen in filters and plugins of music studio software, as well as explicitly generative commercial applications such as Seiko Pro. The creativity of programmers is tapped into flattery of paying users." I don't know who recognizes the quote. Anyway, the important takeaway here is that you should find a language that fits your ideas of conversing with the machine about structures, sound, visual output, or any other medium you might want to live code. And it also raises some questions, like when you live code within the framework or language of another programmer, are you actually engaging in a dialogue with their musical concepts or concepts in general? And what does that mean for authorship? These are just some thoughts I want to put out there. Then I want to go back to the physical entanglement. So the embodied process that we are in while we are live coding. So in this paper from 2015 that I wrote, I made this diagram. This was before I worked with graphic designers who make really cool diagrams. So this is sort of what I came up with. Like, we have these concepts that we want to express in code. Then we are using our motor systems to tell the keyboard these concepts. Then they end up in an editor, and we have a display of what is in the memory buffer of that editor. So we can actually check, are we typing what we intend to type? So that's one feedback loop. And then we send basically what is in the editor is sent to the memory code of a program. We are interpreting that code, and then it goes to the CPU, generating output data, which generates the output medium, and that we perceive again with our sensory system, and that influences our concepts. The same McLean from 2006 and 2011 said something about bricolage programming, which I also think is an interesting concept, which he described as a creative feedback loop encompassing the written algorithm, its interpretation, and the programmer's perception and reaction to its output or behavior. And further on, he wrote there, at the beginning, the programmer may have a half-formed concept which only reaches internal consistency through the process of being expressed as an algorithm. So I want to give another example from my work. This is a performance which I performed between 2013 and 2017. And that was, I performed it for more than 20 times at different venues. And the whole process of that was, going between sort of building the instrument, like the hardware that I was using, sort of creating a composition and performing with the piece. So I was developing code, physical instruments, sonic textures, and also a movement language, step by step. It's a combination of gesture and live coding. The gestures are measured with accelerometers that I wear on the wrists. And then I have 5 buttons on my hands as well. And during the performance, I'm alternating between moving and controlling the sound, and live coding to change the relationships between movement and the sound. Yeah, so one of the concepts when I was with this work, I was also, this also led me to think a lot about, okay, what is this relationship, between performance, building an instrument, composition, and then one of the concepts that I came across from a sort of interdisciplinary improvisation was this idea of instant composition. Combines the notion of working from the moment, instantaneous creation, with the intention to build something, composing a piece with an audience presence. That means that for us, improvisation principles are always connected with both the question of freedom and the question of structure. And I think in that, live coding is quite unique, because with most improvisation, the intended structure is not apparent until it unfolds, because it stays in the heads of the performers. But with live coding, we can actually, as an audience, read the code when it's projected. We can actually read the intended structure before it unfolds. But then also the live coder may decide to change it before it is unfolding. So in a sense, live coded code is a folded structure that will unfold as it is executing. And its output becomes experientiable. But we may at any point intervene in the unfolding and change the course. Just gonna see if this helps somehow. Let's see. So we are continuously creating and displaying possible futures. There was an alternative one. Maybe I will check that one. Yes. Okay. Seems to have done something, hopefully. No. Okay, it's quite fitting it's at this moment. So the live coder is continuously creating and displaying possible futures of the performance and creating alternative futures at the risk of crashing in the moment. And I think that's also what makes live coding unique. The expectations of where the performance may go are made explicit to the audience by projecting the structure. So for the last part of this presentation, I want to go back to the TopLab manifesto. So maybe a quick question, who has read this TopLab manifesto? So that's quite a few. And who has been involved in writing it? Okay, I see one sort of finger there, okay. So I try and unpack it a little bit, and I will see if I can get back a projection. Okay, I'm gonna take this one out. And, okay, but I'm not. So I have to click through a little bit. So I want to unpack the, reevaluate this manifesto. There we are. So it started with a lot of demands. So, and I'll try to perform this. Give us access to the performer's mind, to the whole human instrument. Obscurantism is dangerous. Show us your screens. Programs are instruments that can change themselves. The program is to be transcended. Artificial language is the way. Code should be seen as well as heard. Underlying algorithms viewed as well as their visual outcome. Live coding is not about tools. Algorithms are thoughts, chainsaws are tools. That's why algorithms are sometimes harder to notice than chainsaws. So just to contextualize this a little bit, this was in the era where actually laptops were just about becoming affordable to artists, I would say. So a lot of people were annoyed by seeing a performer with just a laptop on stage, and this was seen as quite boring. So there were basically two reactions to that, I think. One was artists started to explore how to get away from the laptop and create alternative instruments with sensors and stuff. And one of it was the live coders who wanted to show what's actually happening on that computer. Are they reading email, or are they actually doing something that relates to what we're hearing? I also sense that there is a demand for democratization and also empowerment through transparency. Then in the second phase, it starts to get a bit more nuanced. So it says, we recognize continuums of interaction and profundity, but prefer insights to algorithms. The skillful extemporization of algorithm as an expressive, impressive display of mental dexterity. No backup. And I think the first two media for backups show a little bit the time when this was written. Who still has a mini disc player? Who still knows what a mini disc player is? Okay, that's a little bit more. So this is also this reaction, I think, of this physical performance versus mental dexterity, and also emphasizing that there should be risk in performance. Then the last part gets even more nuanced. It is not necessary for a lay audience to understand code to appreciate it, much as it is not necessary to know how to play a guitar in order to appreciate watching a guitar performance. So this was also a reaction to people say like, yeah, why project the code? No one understands it. The code is difficult, etc., etc. So I think that part is definitely a reaction to that. And that's live coding may be accompanied by an impressive display of manual dexterity and the glorification of the typing interface. Performance involves continuums of interaction, covering perhaps the scope of controls with respect to the parameter space of the artwork or gestural content, particularly directness of expressive detail. Whilst the traditional haptic rate timing deviations of expressivity and instrumental music are not approximated in code, why repeat the past? No doubt the writing of code and expression of thought will develop its own nuances and customs. So again, that's sort of, stressing this tension between the body-based performativity, expressiveness and virtuosity versus the sort of mental, the human mind displaying that. The third live coding performance that I made is in a way also an example of this manual dexterity and the glorification of the typing interface by actually looking for a different typing interface, the one-handed keyboard. And actually, first I had this idea of using this keyboard in a performance, and then I realized, okay, I first need to learn how to write code on this. So I created this environment to learn typing with it. And then I had this idea, okay, so we need etudes for live coding, for coding. So that's hence the title. So I started looking for scripts from other live coders that I could re-perform, so I could learn how to perform their pieces. I only found one freely available online from Fredrik Olofsson from a performance in 2007, so that's the one I've been practicing. And then, that also raised some questions for me, like, is it live coding when I'm re-performing this code from 2007, like 12 years ago? But also, like, because there is this moment in this performance where the code that is executed is not doing what Fredrik was expecting. And then he starts searching what he's doing, where the bug is, and how, then he tries to fix it. And when I'm re-performing this script, I'm also wondering, like, should I just do it right? Or should I re-perform these mistakes? Like, what should I do? But I found it really interesting, actually, because I could really, by going through the script in this very close way, I could really sort of follow his thinking pattern. Okay, I'm gonna drink a little sip of tea, because now we're getting to the more... so we discussed the old manifesto, so we're getting slowly towards the political part of this keynote. Yeah, so we're all dancing in the algorithm. So yeah, if you write manifestos, it becomes political. And I think as when you give a keynote, you should transcend the practice a little bit. So I think one of the messages, or maybe the message of live coding, is that you can develop and create your own algorithms. Everybody can learn to code. So I think that's a very important message. Also shows that algorithms are mutable, volatile, and fallible. And that below our everyday fancy GUIs, there is code written by humans. And that we do not need to take this code and the algorithms implemented in them for granted. So we can control the systems that are creating our lives, or that are controlling our lives. And yeah, code is controlling many parts of our life, and we should demand transparency and openness and oppose this technocratic dogma that only experts can code, because anyone can. And also there's this dogma that the algorithms makes no mistakes. That's true. Humans do. And that machines are intelligent. And I think that's one thing they are definitely not. They are just following instructions. So in a sense, we are living nowadays in sort of an algorithmic society, because yeah, it's shaped very much by the machines that we have created. Like information technology is now playing such a crucial day in our everyday life. How our lives are regulated, what advertisements we see, the media that we read, how we get our information. Everything is controlled by algorithms these days. And data has become one of the most important currencies on which businesses thrive. And yeah, companies use algorithms to analyze data, usually selling us stuff, but also policing us stuff. There's a lot happening in that era. And also, if you think a little bit further than IT, then you could also understand the bureaucratic systems that many societies have. As sort of machines that are executing rules and regulations that politicians create. So I guess in a sense you can actually see politics as a very slow method of live coding, but as every rule is negotiated, but it is a sort of changing code in a running system all the time. And where this in particular becomes dangerous, because the information technology is starting to become more and more a part of these bureaucratic systems. So whereas like a bureaucrat still can look at a case and say like, yeah, okay, the intent of the law was this, so it's okay. When it's implemented in a computer, often it's done in a way that you can't really make these nudging of the rules, and you can't look at the intent, but you are only faced with the outcome of applying the rule. So often you have the excuse like, well, computer says no, it's not possible. And that's also what the judges in court, like when it gets that far, often their role is to check like is the outcome of applying the rules, is that actually according to the intent of why the law was made. And I think as live coders we have a very important role in that we actually show and make clear to an audience that the intent of coding something does not always coincide with the outcome. So where do we go? Live coding beyond the screen. First, I have some suggestions for our everyday practice. So one is alternate keyboards. Let's explore other types of keyboards, because this one is getting a bit old. Let's deconstruct the laptop. Let's see. Let's look at programming languages beyond text. And I think we saw a very nice example at the performance during the lunch concert with the code clavier, where actually the piano was controlling the code that was generating the visuals. So let's explore that more, like gestures, images, or otherwise. Let's also look more at output beyond the audiovisual. Let's explore live-coded meals, heat, smell, vibrations, weaving patterns, etc., etc. We saw some nice examples also yesterday with choreography. Yeah, and then also let's look at code beyond the computer. And I think Kate gave some very good examples of that yesterday in her keynote. But let's also explore more like what that means in society. So I want to show one last work, which I developed between 2019 and 2021 and is still in development. So this started as an attempt to create a gestural live coding language. It's really an attempt, because in the process I found it was really hard to work with real-time, time-based gestures that were learned on the fly. This is a problem that has not, and using accelerometers for it. I was also not using a camera. So I had this residency in Sussex, and I was there for 2 weeks, and I had already done some pre-work, but during these 2 weeks I realized it wasn't gonna work out, but there was a performance scheduled at the end of the 2 weeks, so I had to deal with it. So I made a performance out of this process of teaching the machine. Yeah, but the labor that's actually involved in that.
The algorithm needs templates to learn each gesture, so it can be trained to recognize the gesture. The performer will now start the performance. The machine is learning.
My name is Marije Baalman. The performance, the machine is learning, is about the labor involved in generating and categorizing data for machine learning. The questions that I want to ask is who is doing this labor and under what conditions is this labor done?
Store this training sample for gesture 2. Sample stored. Store this training sample for gesture 2. Sample cleared.
So in the performance I'm using time-based gestures that have a start and an end, and I'm measuring these gestures with IMUs, inertial measurement units. To train a machine learning algorithm, you have to make recordings of this gesture, doing it multiple times, repeat it each time, label its type, make sure the start and the end of the gesture is clear. And one way of doing it is by displaying a graph of the data to see, okay, does the data look similar to the previous gesture? So I created a system to be able to do this very quickly within the time frame of performance.
Store this training sample for gesture 13. Sample stored. Store this training sample for gesture 13. Sample stored. End training sequence.
Yeah, unfortunately I wasn't able to perform it yesterday. I ran out of time to prepare and rehearse it. Because one of the things I also noticed of doing this performance that actually remembering gestures is really something you need to train. So, since I only saw one finger about who wrote the live coding manifesto, I think we need a new one. So this is an invitation. The future of live coding is yours. Actually, when I met Julian sort of yesterday, we were saying, oh, there's a lot of faces that we don't know. So the future of live coding is yours. So what is our new manifesto? Where's live coding going to in the next 20 years? So I made a pad. It's a blank slate right now. Let's fill it up. And maybe like at the end of the question round, we can see what is there, and maybe at the end of the conference we can publish this new manifesto. So thanks. Here are some references. So I actually had all these sources. And I wanted to end with a nice picture of a book that I just wrote. I brought 3 copies on Thursday. I wanted to put them on the table there, but then I met some people at lunch. But tomorrow I can bring more. There's a link to pre-order, or you can put your name on the little paper at the desk there. Thanks.
Thanks a lot, Marije, for these provocations. So we're running a bit out of time, and we need to start the workshop soon, but of course there's still room for a few questions, so please come up front and let us know.
I think we actually have till 3:30 when the workshop starts, yeah. I was supposed to tell this at some point. Oh, it's changed. Yeah, okay.
1, 2. Thank you. That was amazing. My question is: you mentioned alternate computing architectures and how sort of the world that we live in today is dominated by machines whose architecture was dominated by companies who wanted to do things one way or not another. Mm-hmm. And in my sort of time researching the history of computing and how things have come to be the way that they are instead of a different way, I came across a sort of very repeated sentiment by people who were sort of really crucial to the development of the field in the early days. Alan Kay is one of the better examples, and he was talking about how they were trying to convince companies that were making computers back in the day to put microcode CPUs, microcode interpreters in their CPUs. So basically hardware level interpreters for high level languages. Mm-hmm. And it sounds like exactly the sort of thing that all of us would like to have today, but none of us do. And how the design of things like the Lisp machines or the Smalltalk computers or all of these devices that were built as a sort of uniform body of code that is constantly there for you to see, to inspect, to interact with and change. So in essence, the computer as a live coding machine instead of us live coding a computer. Mm-hmm. But my question to you now is, what can we do today, given that we live in a world where these decisions are being made by companies that are way beyond our reach, and there's very little that any one individual or any one small company can do to return to different architectures that existed in history but not anymore?
Yeah, that's a good question. Don't know if I have the answer. But I think, I mean, those early computers, I mean, they were built, like, back then, like, it was not all microprocessors. So I think there is some value in actually going back and making the computers from single, like, electronic components. And I mean, one thing which was interesting about these Burroughs computers, they had like a variable bit depth for the memory. So you could actually decide, okay, I need so many bits for this particular type of piece of data. So I think that was quite interesting. And then also, yeah, part of there could be part of the word could be used for the instruction. So there are. Like looking at these old architectures, I think that can give like also new ideas of how to do that. But I think there's also like other sort of horizons where biological things, like using bioart and sort of working with those things, and where computation also becomes part. Or looking at things like quantum computing, which also requires this completely different way of thinking about computing, where it's less about zeros and manipulating zeros and ones, but it's actually a much more complicated process that's happening. I think one thing, I would certainly be interested in and see what would happen if you challenge this binary thing, like, so what if there's a little bit more uncertainty in the computing? What happens then?
So another line for the new manifesto, I suppose. Any other questions?
Hi. This might not be an especially well thought out question, but you said with the machine is learning that began as an attempt to make a gestural live coding language, and then that was hard, and it kind of turned into this piece about the fact that it's hard. I'm wondering, is that still something that you're interested in, like creating some kind of workable gestural language, and how would you approach it, or how are you approaching it if you're still working on it now?
Yeah, it's still a thing that's on my mind. I mean, one thing. I mean, actually using these time-based gestures makes it incredibly slow. I think that was maybe a wrong starting point in any case. So in that sense, actually using more poses, like poses as sort of, that would work a lot faster and could have quite some potential. It's also easier to recognize, so that also helps. And I think, I mean, there were a lot of things which could have been better, because I was actually using gestures that were quite visual, where the method of measuring was actually more focused on the energy of movements and sort of direction from an internal point of view. So there's definitely a lot of things that I would reconsider if I'm pursuing the thing further. That's basically that.
One more question here. Hi, Marije. Thanks. I have a question. When you use this gestural, do you feel that you put us mental effort similar to how we type and we do all of this kind of logical things, or we can get into more, let's say, maybe I will put it, I'm not sure if that's correct, more kind of altered states of consciousness, but I'm not sure if this is a correct term here. More effortless. Do you think that the gestures can be more, can lower the effort?
Well, yeah, I mean, it's still, I mean, as in designing any sort of programming language, you design certain types of constraints and limitations. So you really have to define sort of the sort of operations that you want to do, and how you want to structure that. I think one thing that was particularly complicated was to actually think about, okay, how can I refer back? How can I sort of create a variable and refer back to it? And that was actually quite a challenging thing to do with gestures. But I think it also opens possibilities for completely different ways of thinking about code, and that definitely needs more exploration to see where that can go. Yeah.
Alicia? Last question, I think.
Okay, I'll try to make it make sense then. So you're talking us through this process of where we change the machines and the machines change us, and we embody the machines and the machines embody us, and then we go through this idea of embodiment and an active embodiment that's really about the sensory aspect being embedded in the cultural environment. And then we look at the cultural environment embodied by the manifesto, and you want us to change it. So I'm really curious, like, how do you see that changing the manifesto as, I don't know, I mean, is it not changing fast enough? Has it not kept up with those changes? Do you think it just needs to be reflective of the fact that we change? Or just can you explore that a little bit?
Yeah, I think, well, it's well, I think after 20 years, it's good to renew it, and I think Kate already has made her alternative of the choreographic live coding manifesto, but I think it was Ivan who said, like, well, the community is not reflected at all in the manifesto, so I think. And the world has completely changed, I would also say. I mean, back then, like, laptops were really new, and now actually people, so sort of, I think now actually less and less people are having laptops in their homes or computers. So now we're at a different point where actually people, a lot of people don't have programmable devices anymore in their pockets or in their homes. Like with tablets and smartphones themselves, you can't code how they work. You can't code them. You can have an application that can do a little bit of coding, but you can't recode the machine itself on these devices. So we're actually moving into another era in that sense, and I think that's also something we should reflect on. I'm not sure this is an answer, but it just raises a lot more questions.
Okay, thanks a lot, Marije. That's enough provocations for now.
You'll finish over there.
I have two announcements, or actually a few, but first two announcements are tomorrow at 11 o'clock we want to do this group photo, so it would be nice if everybody could join. And another announcement is to the contributors, please check your email. We want to have this kind of a boat trip on Sunday, and let us know if you want to attend. That's it for me. Now Luca's gonna give a tour for the workshops.
Yeah, so the workshops start in 4 minutes, excellent. Okay, for 19 minutes. Thanks to production crew. There's 3 workshops in this space. The Visualist meetup in the big room. The Expressing Yourself with Code world building workshop behind this door, and Animatron visual poetry in the lobby there. The 4th workshop, Live Lily, is in the big building there. It's in a space called Room 31, and you will see on the corner of that building going out is a fire escape, which you use to enter, in this case, the room. Maybe one final note, I think for most of the workshops, you are invited if you registered for them, except I think for the Visualist meetup, it's like no problem if there's more people than actually registered. Okay, thank you.
Hello, sorry, I have one more announcement. If everybody could sit down for 1 minute. Actually, someone of our production crew is its birthday today. Her name is Juliette, so if we could all call her. Juliette? Juliette? If you could come to the front and we can all sing happy birthday to you. Even though you don't want to, you kind of have to. And all sing with me because I have a horrible singing voice.
Day to you. Happy birthday to you. Happy birthday, dear Juliet. Happy birthday to you.
Okay, now you can go.